Cool. Thanks everybody for coming today. Yeah, I'm very happy today to talk about our workshop on computer vision, fashion, art, and design. This is the seventh edition of a workshop. And yeah, this is a joint effort, obviously, with the organizers here, which unfortunately most of them couldn't be present today. But yeah, Ziad, myself, Noor, Julia, Leo, Nagar, Reza, and Maria. So thanks to everybody for organizing this. Why are we meeting up today and in the past seven years? It's because we know that creative domains render a big part of modern society. They have a strong influence on everything that we do, from the economy to cultural life. And we want to focus in this workshop, we specifically want to focus on domains such as fashion, art, and design that centers around the creation, consumption, and manipulation, and analytics of visual content. And obviously here we want to capture new trends, ideas in machine learning AI that has an impact in creative domains and the other way around. And we want to bring together a very diverse set of people like artists, designers, researchers, and engineers. So first of all, I want to thank the keynote speakers we'll have here today and partially virtual. So Karsten, Noof, Jason, and Jambing. So happy to have them here and excited to hear about their work and yeah and also I want to thank our sponsors. This year we have a new sponsor, Zozo Next. So thanks to join the effort in contributing to this workshop. And obviously we have Zalando that has been sponsoring this workshop from the beginning. We want to thank also the reviewers. We have a list of reviewers here. Thank them. Without them, wouldn't be possible to have such amazing papers here. And yeah, we have 8 papers that has been accepted to the workshop out of 21 submissions. So all the papers are going to be spotlights. So we will have a session later with spotlights, and then we will have a poster session. And yeah, all the papers, talks, posters will be available in our website. And we also have 2 paper awards that we will announce at the end of the workshop during our closing remarks. These are the topics that we will be talking about in this workshop in terms of accepted papers. So we go from fine-grained fashion, retrieval and recommendation, to body estimation, to fashion design and ideation, virtual try-on, and virtual orchestra. Yeah, so in a nutshell, this is the agenda. So we'll start from the opening remarks, which is happening now. And Noof is going to give the first talk about the simplification of culture and artistic perspective on computer vision. And then we will have other talks from Karsten. And we'll have the spotlights. After the spotlights, we will be at the poster session, which will be not in, I think, not in this building, but at Arch, which is building next door. And we will have, after this, the poster session, we will have 2 other keynote talks from Jason and Jambing. And finally, we will have closing remarks with the best paper award winners. Yeah, so I want to also advertise another workshop. It is kind of a Simlink workshop, which is happening in the afternoon. It's just about creative applications in computer visions. And the poster session from our workshop and their workshop will be next to each other. So if you want to have a look at the other posters, just go ahead. Yeah, without further ado, I would just start with the first keynote speaker, who is Noof. Please, you can take over screen sharing and go ahead.
Thank you so much for introducing all that. Gonna start sharing my screen. Okay, present. Okay.
Oops, sorry. Give me a second. I need
okay.
to. share it here too. Where is it? Okay. I think you're all set. Thanks.
All set. Thank you. Okay, hi everybody. My name is Naf Aljuiser. I'm a new media artist researching personal and intimate questions with AI and creating artworks around that process. My talk is called The Simplification of Culture, an Artist Perspective on Computer Vision. And today I'm going to discuss how my journey began in experimenting with computer vision techniques for a commercial project and how slowly, as I investigated them from an artistic and personal lens, that process took me to the statement of my talk. So I was first introduced to this world in my first job after finishing my master's degree. I was working for an advertising agency called Havas, and our goal was to rebrand our client, ADP, which is a payroll company, using AI. This was back in 2018, before all the current AI hype, so we didn't fully know what we were doing or what was even possible. There were many papers available in open source GitHub repositories, and I started playing around with earlier models such as StackGAN, text-to-image, style transfer, and more.
Sorry, there are some issues. Can't
Oh,
hear you anymore in the room.
you can't hear me? I'm sorry.
We can't hear. No.
Oh, can you hear?
Yes. Yes, now, yes. It was stopped at some point.
Oh, that's weird.
Yeah.
Let me see.
Now,
Select.
now it works.
Now it's fine? Okay.
Yeah.
Um, can you still hear me now?
Yes.
Okay.
Thanks.
All right. So I think, yeah, I was saying that I was just kind of experimenting with these earlier models, and my task was to understand the creative bounds of each technique and how that could be applied and scaled to our client ADP. We ended up choosing style transfer because it was an easy model to use. It didn't need a large data set to train on. It just needed one, and then it could stylize hundreds of images and videos that you could give it with that style. So the technique was pretty convenient and scalable. And in a way, it kind of fit this premise of how can we make AI the artist of ADP, because it became proficient in learning like this one style. But we had to continue experimenting because we, as you may know, like many of these techniques can be a black box. So we couldn't really predict how the model would exactly stylize images. So we would create different types of patterns, we would train the model, and then we would study the results. So for example, in this pattern on the left, we saw that the result came out as a very intricate and web-like pattern. And in this next pattern to the left, that's more of like a block pattern and more a bit stronger colors. The output came out as a bit harsh and with rougher edges, and it just didn't feel quite right for the client. And to be honest, we didn't really know what we were looking for. This was really about collaborating with the AI technique, training it, like doing some tests, and trying to see what we were looking for through that collaboration. And this next example is this pattern was testing like more organic and delicate shapes, which produced this really beautiful, also intricate and organic output, which was kind of getting closer to the aesthetic we were trying to aim for. And we also tested stylization on videos as I was looking at a style transfer technique that uses optical flow to smoothly apply a style frame by frame across a video. So I made some tests to just make sure how can this style perform and move in a moving image. And finally, after these tests, we came to our style. We called it the uplifting style. It's an overlapping pattern of line, dots, colors. And when we trained it, it just created this really beautiful repetition and integration of all these elements in one image. I'm going to show you how this came out in our launch video, where you can see how the uplifting style played in the overall brand. So something interesting that we did in post-processing is that we edited the uplifting style to not fully stylize the full image. We wanted to crop out the human inside the image because we wanted viewers to connect with people or humanity. Um, so so the video that you saw, there was a bunch of post-processing to do that. But after that, the style was then applied and used across ADP's websites, brand, campaign assets. You could probably see it somewhere out in the wild now. And it was a huge success as this is I think at the time, the first commercial project that really used a visual AI model in this way. It was quite innovative. And, most people were also just confused about what we were doing. So I was very proud to be a part of this. And after exploring these new technologies in a creative and commercial space, I wanted to see what else AI is capable of from a personal and more intimate perspective. I had learned how to set up these complex models, train them, test them, have this collaborative workflow with them. So I felt inspired to continue and extend my skill set as an artist. Specifically, I was curious to see, can AI tell me more about where I come from? Identity has always been an important subject. After leaving my home country, which is Saudi Arabia, and coming to the United States at 13 years of age, I started losing a sense of belonging. My identity felt fragmented and complex as I got older in the United States. So I wanted to study this question and from the perspective of my family, but also that of AI. And I wanted kind of a relationship and connection between the two things. I started interviewing my mother and I traced my family history to the 1800s, which was crazy because I had never asked her or known about this history at all. I learned that my ancestors migrated across Arabia, Mesopotamia, which today is modern day Iraq, and almost had a very similar migration story to myself. They had gone to different regions, such as like Basra in Iraq, Zubair in Iraq, and they were just seeking opportunity. And it was just really heartwarming to kind of see this connection to my ancestry. And in order to have a conversation with visual AI models, I first needed to collect data, of course. For each decade, in my mom's story, I began collecting images, and I specifically scraped museum historical archives of the regions and the times my family lived in. Anything that could give me a sense of what people ate, how they looked, where they lived, etc. So one of the first data sets I collected was from Gertrude Bell. She was a renowned British explorer that accompanied Lawrence of Arabia as he journeyed in the Middle East, and she was known for just taking a lot of pictures during her travels. So in some of her data sets, I saw images that were very relevant to the regions that I was seeking. But when I found these images, this is where I encountered my first issues in my data collection. Primarily, these regions did not use photography as a method of documentation, so I had to rely on several colonial archival materials. And the issue is that these photographs are taken from that like British Empire perspective, which sought to depict the Middle East in a very exotified and Oriental manner. So one problem, the British colonial gaze, and the second, as a consequence of that, is lacking a native, authentic self-expression. And lastly, because women are protected in these cultures, there's not so much documentation of women. So it was unfortunate for me that I just couldn't find a lot of representation of that in these images, especially like the older time periods that I searched. Another data set that I collected from the Getty Museum is called the Orientalist Collection. That were British colonial pictures from the 1800s to the early 1900s. And similar issues as before, colonial gaze, lack of expression, not much women. And as the title suggests, these subjects feel overly posed, they feel exotified, they feel unnatural. And I wondered what the real versions of these people would be, and it just didn't feel it didn't kind of match the story that my mom was telling me. So the first limitation in my quest was data. How do you collect information on and data on a culture that was colonized and didn't natively use the camera or visual methods as a way of documentation? So then I took these data sets and I tested them across several commercial computer vision models. Specifically, I wanted to start with the fundamentals of computer vision, object detection, image segmentation, and I was curious to see how and what AI sees in my images, how it sees my culture. I wanted just to kind of start there. Let's define things together. And the results were a mix of biases, generalizations, stereotypes. So for example, in this test, I tested this nomadic Bedouin data set that I had. I think it was from Gertrude Bell. And it's featuring a Bedouin man next to a woman sitting next to their tent. And a bunch of the labels that came out at first were militarized labels. So military, army, armored soldiers, which was quite shocking to receive and had made me feel like the training data set for that model had been trained on militarized images, perhaps of the Middle East. Another test that I did is for testing modern day Saudi women, Saudi men, what they traditionally wear. So for women here, they're wearing an abaya, a niqab, and for men, he's wearing a traditional shmagh and agal, we call it. And I noted that it tagged these cultural artifacts with labels that were Western and with very high confidence rates. So for the women, it tagged it as costume, poncho, dress, and for the men, it would tag it as hat or turban, which is culturally inaccurate, and made me also feel like the training data set perhaps was more skewed toward South Asian representation, perhaps. And and overall, I just had a problem with these models detecting like women who are wearing like the full covering. It would say, maybe this is male, maybe I'm looking at a face. It wouldn't exactly know. And there's so many ways of how women wear the niqab or the abaya. And so it would just constantly the results were just kind of all over the place. And so through this process, I uncovered a story very different than what my mother was telling me. I encountered an erasure of ancestral memory, a generalization of culture, similar to how the British sought to generalize the Middle East as the Orient, and feeling like the past issues were connected to these models' failures. And I created two works from my research and process. The first is Salaf, which means ancestors in Arabic. It is a series of visual portraits symbolizing erasure. So using the same tools that detected and labeled, I used the image segmentation model to instead inverse and remove my subjects because I felt like that act erases this colonial gaze and highlights the absence of ancestral stories and memories, and kind of provides some justice for the story that I was seeking. And I applied this to all my images, and I then use this empty data set to train a generative model. I did some style GAN training because I wanted to reflect on my process and I wanted to regenerate that absence as a figure that is present and dominant in our technological world. And I think the results are really just sort of interesting of how this white figure kind of repeats and manifests itself in this generative piece. Um, and the second most recent work I created is a film called Ana Min Wain, which translates into Where Am I From? This is a short film that's a conversation between me and an AI character trying to answer the question, where am I from? I'm going to play a small trailer of the film so you can get a sense of what that looks like.
Where are you from?
I don't know where I'm from. Part of me is from Saudi Arabia, where I was born, but another part of me is from the US, where I immigrated to and have been living since then.
Calibrating? Where are you from?
Part of me feels like I'm not from one specific place, that I'm fragmented from different pieces. Ana Minwen.
So, as you saw, I juxtapose my story and my mother's story later in the film against AI, and I show how my culture was reduced to a degree that doesn't exist, how I found belonging and a more human connection to oral storytelling and the poeticism of identity belonging to fragments of my life from my mother, from different places I visited, from my memories, and from basically everywhere. And I do think you can use AI in creative and exciting ways, like I did in my commercial project. However, testing how AI applies to culture revealed many layers of problems. So one is the obvious problematic data collection, um, and two, how biased and reductive computer vision models can be when it comes to interpreting culture. And I think this reductive nature comes from us humans. Our brain is wired to find patterns and simplify information. However, as humans, we also have nuance. So our first impression when we see something, it's not everything. You know, we have real intelligence to think through things. We might think we might have a certain bias in my head, or even for me, like I have certain biases that come up, but I've learned to detect, pause, and be careful about it. And kind of AI doesn't really have that. It's trained to always give an answer, even if it's wrong. It doesn't really know that it's wrong. It doesn't really know that it's problematic. And so this act, this human act of reducing each other is then, applied to algorithmically and it's multiplied and creates even more damage because, of course, when you scale AI, it has a much grander effect on society. Um, and it's been crazy to witness how AI has spread in popularity and it's being applied in every sector. And I wanted to discuss a moment of how my learnings apply to the current AI trends and what we can do for the future.
I know, still same
Oh,
problem
oh,
right now as audio is gone again.
okay. I'll shit. Do you hear me now?
Yes,
All right.
thanks.
Okay. I don't know. Okay. I gotta keep sharing, I guess.
Yeah,
Okay. Okay, just let me know. So yeah, I think I was just saying like I wanna tie my learnings to the current AI trends. And so with the explosion of GANs specifically, I think that we see this flattening and simplification of culture continue to manifest and multiply. So I used Photoshop's generative AI tool and I just made a simple search of Saudi Arabian woman, and the results were pretty crazy. It created these like women wearing what men would wear. It also had light Caucasian women. It also had like tiny heads, no heads. And just essentially just a repetition of what happened in my research that I see happening with GANs. And I think I'm showing GAN also because I think specifically it's become so popular, and I think it's a quick test of how you can see what's inside of a model and what is it's being trained on. Um, and I also wanted to highlight this article that I read from Rest of World, their GAN analysis. Rest of World is a global nonprofit publication covering the impact of technology beyond the Western bubble. And they wrote this piece of how AI reduces the world to stereotypes. So using Midjourney, they chose 5 prompts based on generic concepts of a person, a woman, a house, a street, and a plate of food. And then they adapted it to different countries. So for China, Indonesia, Mexico, Nigeria, and India. And what they found was that the results show a hugely stereotypical view of the world. Perhaps what the first image that comes to mind when when somebody mentions a certain culture. So an Indian person is almost always an old man with a beard. And a couple of the images even merged Native American with Indian culture, and there was just ambiguity around the term Indian, which was interesting. Um, this was another example of like Indonesian food was just almost exclusively served on banana leaves. And in this next example, a Nigerian person was either a woman with red, yellow, and orange headdress, or a man with and also with big earrings, big necklaces, or a man with a cap. And, for all these cultures, they're home to so many different like languages, ethnic groups, hundreds of distinct cultures. All these groups have their own traditions. And so from a visual perspectives, there are many versions of Nigeria, there are many versions of India, but instead we're just being presented as one, and again, we kind of see a flattening of our world and a reinforcement of how the West views other places. People from other countries don't wear traditional clothing all the time. Sometimes they wear shirts and jeans. But unfortunately, these models are being used, in advertising agencies or in sectors, and they're using it in a way to create more diversity by being able to search for any prompt that they wish. But I think that diversity is inherently problematic because it's not truly diverse or representative of the culture of the people. Um, my short film was released on the New York Times last week, and there were a bunch of comments left under my video, and people were having really interesting debates around my film. And this is a comment that I thought was interesting that I wanted to share. Somebody said, "I don't think AI is inherently good or bad. It's just a tool. When I use a butter knife to loosen a screw because I'm too lazy to get my screwdriver, I can't be sure of the results of my labor. In order to get a job done and do it, well, you've got to use the right tool." And I think this is the exact problem I want to highlight, is that I think with the current hype around AI is that people don't think about these factors when they use these models, the factors that I presented today. They see AI as accurate. They see it as a means to an end. They see it as a butter knife tool. So unfortunately, it's reinforcing, this human approach of like reducing each other, because people are not able to kind of perhaps see that. And I've been thinking a lot about these two questions, which I'll leave with you here for the future, and which will be part of my future work, is how can AI learn from stories and not data sets? How can we learn from traditional storytelling practices to make sense of the diversity in this world? How can we pass down oral storytelling to machines so that we don't lose the nuances of human memories and life itself? And yeah, I'm probably going to be thinking more about this in the future. So thank you so much. That's all I have.
Thanks for the talk. Any questions from the audience?
Thanks, Noel, for a very, very interesting talk. I was wondering what we can do as a computer vision community or like machine learning research community to help with addressing these issues better, or like integrating culture better. Like, what's your recommendation for us?
I think that I've been thinking about this because I think, I don't think there's one person or one group of people that's going to provide the perfect answer of what is culture. Like culture it has changed and manifested so much, like throughout history and throughout as I kind of figured out in my research, so there's a lot of nuance, like historically, and also in present day life. So I think I've been thinking a lot about, collective kind of intelligence and like working with like different collectives of people to make sure that is a culture being represented in the right way, and can we can we have like discussions with many like collectives of different people that represent this culture, so that we don't always, and can we move away from just from relying on visual media? Like, can we talk to these people and, you know, and collect all these stories and make sure that these stories are somehow going into the model? Because I think visual media inherently is lacking. It can be absent. So, and even, you know, if you go all the way back, you know, we pass things down through oral telling or written stuff. So I think starting from like these stories and then thinking about passing it down to the models. I hope that made sense.
Thanks. More question? So I do have a question. You know, you've been working on this field for a while now. Have you seen any shift towards the right direction? And if so, you know, is there any positive shift that you've seen, what we're doing? And can we, I mean, also the previous question was about, you know, how can we make it better and how can we
Right.
reduce these biases? Yeah, I wonder if any of that we are going into some direction that is definitely interesting or not.
I think well, I've been following very closely about what's happening, you know, in terms of commercial trends over like what Google's doing, what all these companies are doing. I think all of that are pretty negative for me, because you know, like especially the AI overview feature, like you can see on Twitter, it's like blowing up and it's saying all kind of inaccurate facts. So in terms of commercial stuff, I think commercially, you know, it's too fast paced and it's erroneous. And it's causing, you know, causing like really harmful damage. But I think I also heard about this positive thing lately of like researchers are looking into how they might be able to know what a model is gonna like output before, like how is it's thinking about sort of things. And we're starting to be able to understand how, you know, we're not just like, you know, back when I worked with this, right, we didn't know that. We just saw the output and we're like, okay, somehow it produced this. I don't know how. But now we're kind of able to understand these inner workings. And I think that could be like a positive step in terms of like, if we better understand that, then maybe the results wouldn't be so bad as what I encountered.
Cool, thanks. And also about, you know, you mentioned that we need to shift our insights from data to story. So, and in our community, actually, we rely a lot on data. And obviously, all the models capture these biases because the data comes from well-known, you know, distributions, and we miss the long tail. How do you have any idea towards the direction that we could leverage and make better these models? Not just rely on data. Data will be always there, but how can we make it more like somehow useful and connected to stories?
That is a good question, and I don't know if
I
I
mean,
have
that's a
the
big
answer for
topic,
that.
but yeah.
That's a big topic and something that I want to keep thinking about. But I mean I've just been thinking about like why is intelligence like, you know, I think when intelligence was sort of defined of like I see this or that, like how come it's been defined in this way? And is there kind of another model of intelligence that can draw connections between stories rather than drawing connections between like words and like certain pixels and stuff like that? Like, is there just, can we come up with this other model that connects storytelling to the images or something like that? And I don't know the specifics of that yet, but it's something I've been thinking about.
Sounds good. Gives a lot to think about also to the computer vision scientists here in the room. Yeah, thanks. Any other questions from the audience? Otherwise, let's thank the speaker again. And thank you for your talk.
Thank you so much. Thank you so much.
Cool. Now we move on to the next speaker, Karsten. He will be talking about generative AI as artist paintbrush. Yeah, I will let you. Oops, sorry. Let me mute myself. Good, now I can see you.
Oops. Actually, 1 second.
Yeah. Okay. And order if you want. Are you unmuted as well? Yeah. Okay.
All right. Can you hear me and see me well also online?
Yes, we do.
Perfect. Okay. Should I get started?
Yeah. Yeah. Carsten will give a talk about generative AI as artist paintbrush from diffusion model to for the dynamic content creation. Thanks, Carsten.
Okay.
Carsten?
Yes. Thank you very much. Before I
Sorry,
get started, I would like to thank the
Carsten?
organizers. Yes.
We see your presenter view on Zoom.
Oh, okay. Sorry, let me fix that.
I didn't know.
Let me unconnect you first. How is it now?
It's good.
Okay, perfect. Yeah, before I would like to get started, I would like to thank the organizers for inviting me to this workshop. So I'm a research scientist at NVIDIA. I'm not an artist. I'm not a designer. Whether I'm fashionable or not, I don't know. But it's my pleasure to be here. So I have been like just working on the science side of things. And for the last few years, I have been working primarily on these generative AI systems, diffusion models for like images, videos, 3D, 4D, that type of thing. And so that's what I'll talk about essentially. So when I think about, but then I thought about what should I talk about here, right? This is more about art, design, this workshop, and I want to talk about the tools for doing that. But when you traditionally think about what an artist might be, there are so many different ways to do art, right? And like maybe before the rise of generative AI or even computers, so we all think about different ways when we think about what an artist or a designer does. So I was like, okay, let me actually ask ChatGPT, like an AI system, what might be an image of an artist. So you may query the model in different ways, but you may get an image like this. I guess it's clear to everybody that being an artist can be much more than just using a traditional paintbrush and painting a picture. I asked the model, like, can you provide an image of a designer to me, you know, in classical fashion? It might be like that, what ChatGPT gave me for that. But I guess like an artist can also be much more a person using these new generative tools that we have now doing, yeah, very cool and expressive things with that. And if you look at what these systems can today generate, here are a few images generated by DALL-E 3, EMU, Stable Diffusion. It is quite impressive, the type of expressivity we see. The speed in this field right now is crazy. Just today, like Runway announced a new video model. Last week, like Luma announced like a new video model too. It is quite outstanding. And it's not just images, the type of video generative models we see now, it's very cool, but then there's also like models that generate 3D objects, like at the lower left. So these are not just images, there is an underlying 3D object. And now people are also exploring, you know, dynamic 3D content creation, like you see on the right-hand side. So there's like, these can all provide interesting tools for artists, I believe. Yeah, so what will I talk about in my talk? I'll give a brief like overview about like these image and video diffusion models that essentially have taken off over the last few years. Where are we? What's missing? What's next? And then I will talk about some technical ways on, you know, not just generating images and videos, but, you know, like to do like 3D content creation, dynamic 3D content creation, which we call like 4D. I will talk about two papers. One is Align Your Gaussians, which we present here as a highlight poster. It's a technical paper on text to 4D content creation. And I will talk about another work that is to be released very soon, which is also for 4D content creation. Yeah. So this talk is going to be also a little bit technical. So I'm a research scientist at NVIDIA, right? And so let's look at how diffusion models work first as a bit of a recap. So what you do in these models, you have data given. This is kind of like the images, like here images of these cats. And then you progressively add noise to these images until you get random noise. You see this here visualized at the bottom. But more conceptually, if you just have a one-dimensional toy distribution, you can think about it as that this distribution kind of diffuses towards a standard Gaussian distribution. And then when you want to do generation with these models, you basically do the reverse direction. You can just sample this random noise, and then iteratively you refine this noise towards generating new images. And to go the other direction, you actually have to learn a model, a big neural network that performs this iterative denoising. So that is what's going on under the hood. And kind of these types of technologies have now brought us the capability to really generate quite impressive outputs. So here are a few samples that kind of stood out to me and that I gathered from the internet that seemed like particularly artistic, stylish, maybe photorealistic, some of this to me. Yeah, I want to highlight this image at the top right. If I recall correctly, this is a somewhat well-known image in the field. It was the first image that somewhere in some art contest like won a prize actually for what it shows, I suppose. And this sparked a little bit discussion. It was the first time that an AI generated images won something like that. Yeah, so here we are. Now these days, people have also been generating videos. So these are some early results from video generation that we have here. This is like from 1 year or 2 years ago. This little teddy bear is from a model that we developed at NVIDIA back then. But more recently, like the video generation has also completely taken off, I believe. OpenAI released this famous Sora model. I guess this video of this particular video has been shared a lot. You can see that these video generative models, the level of photorealism that we have there now is quite outstanding. The reflections and the physics essentially is also quite impressive. So how did these video models work? Like when you think about these image models first, I want to first like how early models did that explain to you. So initially, or when you think about just an image model, right? It is this stochastic process that progressively denoises random noise into images. Now let's suppose you run many of these stochastic processes in parallel. Like that is what depicted here on this axis. You might get independent images. But what you can then do is you can kind of take such an image model and fine-tune it even on a limited number of videos so that these different stochastic processes that generate you different images are temporally aligned and form a video. So that was an idea that some of these very early video models have employed, and we also did that in a paper in that we presented last year at CVPR, which is like a latent diffusion model, like stable diffusion, and we turned it into a video generator by training it on a somewhat limited amount of video data. How this basically works is, so you have this pre-trained image model, which is defined through like what we call here spatial layers. So these are like neural network layers inside the model that process kind of only the spatial directions. And this is pre-trained, like this can come from a model like stable diffusion. And then you insert these additional temporal layers that act in this additional temporal dimension that you now have when you go from images to videos. Yeah, and these spatial layers then interpret the frames of a video as independent frames, like independent images, but they are still pre-trained to generate nice frames, right? And then you have the additional temporal layers that lead to this temporal alignment. So this is how early models did that. Yeah, you can train both of these layers. You can only pre-train on images and then only train like the temporal layers afterwards on videos, things like that. Yeah, but at this point, so this was like an early model, like from 1.5 years ago. At this point, this kind of latent video diffusion model framework has really taken much further. For instance, this model by OpenAI, Sora, this is also a latent diffusion model. It has a spatial temporal autoencoder that then uses these large transformer architectures that we have also seen in language generation and for video generation, and the results are quite strong. Yeah, so what this model apparently does, it's a spatial temporal autoencoder, then it has these encodings in latent space, where you then do these types of patch style embeddings similar to vision transformers. Then you define a diffusion model over these patches and have a big transformer to kind of model that latent space and model videos. So and the videos you get out of that, that is quite a bit better. I don't want to spend too much time discussing that. I've actually seen that some of the Sora authors are also here at CVPR, so check out their talks, I suppose. So where are we and what's missing? So actually there were like many things missing, I suppose. All these models are primarily controlled through text prompting. They certainly lack fine control, like how can you like move one object in an image to the right, to the left, the detailed arrangement. So text control can only give you really so much. So there's clearly a lot lacking there. Another issue with these models is to make them useful for many people, it's a synthesis speed. The generation is often slow. I've explained to you that it's this, when you generate from these types of generative models, it's kind of an iterative denoising that you perform. So you have to call the same model over and over again to even just generate an individual image or video. Moreover, these are huge models at this point. So clearly the generation is slow. There are many people working on this, but I don't think these are solved problems. And then another thing is, while this image and video creation that we see is impressive, and I'm very impressed by where this has been going, our real world is not just made of pixel grids, right? So it is 3D, it is dynamic. So can we model this more directly? Do we also have generative tools to directly model the 3D world? Of course, there were also many people working there, but this is not as mature as image and video generation, I believe. So there is large scale and complex 3D generation, dynamic 4D content creation, these types of things. These are just a few things that come to mind from the technical perspective to make these models useful and what is missing. But of course, there are many, many more aspects to that. We have heard the last talk, for instance, the understanding of what these models learn, the inner representations of these models, the biases of these models, that all needs to be studied and understood much more. So this is very important. What I want to talk about here is this dynamic 4D content creation. That is something we have been looking at a little bit at NVIDIA recently as kind of another way to, for content creation and I guess maybe also like artistic and design purposes. So why would you want to do that, for instance? Here are a few images from like computer games, like on the left-hand side, these are snapshots from Cyberpunk 2077. When people develop these computer games, game designers, like often these are really complete 3D worlds that are very manually created through a lot of labor. So you cannot get away with image or video models to create the content for this, but you actually have to create proper 3-dimensional dynamic virtual worlds. So if you had AI tools to help you with that can assist you with the creative process there, that would be useful. Or maybe you're like fashion designer and you want to try like do this virtual try-on sort of thing where you want to have a 3D model that can move. maybe you want to create like a dynamic environment, like a world where you can train like and model like autonomous cars. And so there are many applications where like only image and video generation surely is not enough, even beyond pure artistic creation. When I talk about 4D content creation, so what do I really mean? So what I mean is kind of 3D plus a temporal dimension. And here are a few examples of what that's supposed to mean. So you have these little 3D objects here that are actually dynamic and moving. And yeah, this sort of stuff. But I guess this small scale here is all we can do at this point. But before discussing 4D in detail, let's actually recap static 3D content creation, how this technically works. So I will now go a little bit into technical details. But yeah, before that actually, so the types of results that we get these days, if you just want to generate like 3D objects from scratch, it's like this type of stuff that you should see on this slide here. So it's all very object-centric in a way. So we are probably not yet at the stage where we can generate faithfully entire scenes. So that's sort of where we are. So this is one model, like Instant 3D it's called. That's another work that we presented last year at CVPR. So it's a little bit outdated, but I just want to give you a flavor of that 3D generation is essentially like a lot of the research these days is about this quite object-centric generation. Yeah. So how does it work actually under the hood? How do people train these generative models of 3D objects? One thing to recognize is there is no internet of 3D objects in the same way. Like we have like massive amounts of internet, like images, video, language, and so on. So the types of data sets you can train on for these models are definitely a lot smaller. So that leads to the questions, how can we like leverage existing image and video foundation models and learn from them, distill from them like actual 3D objects? So, and that can be done through this score distillation paradigm approach. So I want to briefly introduce that because our work also very much leverages that. However, this was introduced in the Dream Fusion paper in 2023 by Ben Poole and from Google and others. And how does it work? So let's suppose you have a three-dimensional object that is parameterized with some learnable 3D with parameterization. That could be a mesh made of vertices. That could be a 3D Gaussian, so a lot of 3D Gaussian points in space. That could also be a neural radiance field. There are many options. The point is it's learnable. And so now on this image here on the right-hand side, then on the left of that image, so you have this little rabbit that holds this carrot. Now this depiction here is supposed to mean that this is a learnable parameterized through a learnable 3D representation. What you can now do is, when you have this learnable object, you can render this object from different camera perspectives, depicted here, and you do so in a differentiable manner, so you can backpropagate gradients through this rendering process. And when you render this, you will now have different images of this three-dimensional objects. You can take these two-dimensional renderings now and give them to a large pre-trained text-to-image diffusion model. But this text-to-image diffusion model, it has beforehand learned what a good image looks like for this given text prompt, which here for this example is a stuffed gray rabbit holding a pretend carrot. So, and if now this 3D representation leads to a rendering that is very off and this doesn't really make this diffusion model happy, this diffusion model can generate like a feedback or a gradient that you can then backpropagate through this rendering process back into the 3D reparameterization to adjust the 3D this 3D representation such that it renderings, this 2D renderings look more like images consistent with a large-scale image diffusion model. And yeah, if you do this from all different camera directions, and the 3D object, or like its 2D renderings look like realistic renderings, like realistic images of a 3D object, then there is a good chance that the object itself is actually a properly 3D consistent object. So this is the score distillation paradigm that many people have been using to generate these like three-dimensional objects from image models or video models now even too. So this sounds a bit simpler than it actually is. This approach has a lot of caveats and is a bit fragile, but there's a lot of follow-up work now that makes this better and more stable. For the more technical part, I also want to describe a little bit under the hood what is being optimized here. So formally, what is happening here is that you minimize a reverse Kullback-Leibler divergence from the rendering distribution or the diffused rendering distribution to the diffusion model, or the distribution defined through the diffusion model. So strictly speaking, then theta here represents the 3D reparatization. G is now the renderer that renders this representation into different images X. Now you diffuse these images X by adding some noise to it. This corresponds to what I've shown you in one of these very early slides where I've shown these stochastic differential equations. And now you have a distribution over these noisy renderings. And then you can basically minimize the mismatch between this distribution and the model distribution. So this is, strictly speaking, the objective that is being minimized. You can further transform this, but let me skip that. Now we ask ourselves that many people have been using score distillation to generate these static 3D objects. But well, our world is not static, right? Our world is vivid, dynamic. So we were thinking, can we now use these emerging video diffusion models to do similar score distillation ideas and generate dynamic objects? So this type of generation seemed quite underexplored, but very interesting too. So this is the work aligning your Gaussian text-to-4D with dynamic 3D Gaussians and composed diffusion models that we're presenting here at CVPR as a highlight poster. Come by our poster, I think it's on Wednesday or something, if you want to learn more about the technical details. But I want to present a little bit overview. So this is the main pipeline figure. I guess this is a bit overwhelming if you first look at it. So let me go through this one by one, piece by piece. So first of all, we need to think about like our dynamic 4D objects that we have now. How do we represent them? What is our representation? So for that, we use 3D Gaussians, which are just a little, three-dimensional blobs floating around in 3D space. So I think this cat might be made about like 100,000 of them. Each of these Gaussians has a position, like its mean, has a scale, a size, it has a color value, and an opacity. All of this is learnable and optimizable. So this is a static 3D representation. But then these Gaussians also have to move around to capture the dynamics. And for that, we use the technique what's called a deformation field, which is a little neural network that takes in the XYZ position in space together with a time step. And then the time then captures, the time dimension and tells us how this Gaussian point cloud essentially deforms. And that will then give rise to these moving dynamic 3D objects. Okay, so this is a representation, and this is depicted here. What you can do now is you can, at different time steps, like here we have 4 different time steps, you can render these images, like I've just explained. But now if you render that in consecutive time steps, what you will get is a video out of that. And well, you can now take these snapshots and feed them to a text-to-video model that will now give you feedback, like I've just explained with the score distillation paradigm, to make sure that when these Gaussians move, or like this 3D object moves, so that all its movement look like a proper video if I look at it from different perspectives. What you can do additionally is you can also take the individual frames and just give them to a text-to-image diffusion model. So this is kind of complementary in the sense that this text-to-image diffusion model, it will not capture the temporal dimension, but it will make sure that each individual frame kind of obeys the laws of an individually nice image. The reason for that is that when we did this work, these text-to-video models were not quite as robust and stable and mature as text-to-image models. So combining both the feedback of a text-to-image and the text-to-video diffusion model actually helped stabilize the generation significantly and was kind of crucial. So really the text to video model then was responsible for making sure you have the temporal smoothness and yeah, capture that right. And the text to image diffusion model also helped with the individual frame quality. Let me briefly go over the complete list of ingredients here, just so you get the full picture and summarize it all. So we use a 4D representation. So it's, yeah, these dynamic 3D Gaussians with a deformation field, as I've explained. And actually, overall, this model consists of even more models than I've just explained. It's not only a video and an image model, it's actually yet another text to multi-view image model. So that model, given a text prompt, it generates you several images at once, which are multi-view consistent images of a 3D object. So all these models are combined together to provide feedback in the score distillation process. So this video model leads to temporal consistency. For that, we used a new version of this old video LDM model we had at NVIDIA, but this is by no means comparable to any of these latest video models that we have seen. So for the text-to-image model, we use Stable Diffusion, and this multi-view image model is a model called MVDream. So overall, we follow a two-stage approach. We first optimize a static 3D shape that just optimizes these 3D Gaussians. And then afterwards, we optimize this deformation field to make them move. So this makes the whole pipeline much more stable. We found that we were not able to do this at once. There's a whole bunch of other techniques. We have like some motion amplification mechanism to make these objects more dynamic. There is some regularization going on that these 3D Gaussians, the overall size of these objects stays somewhat consistent throughout the optimization. We have some schemes for temporally extended longer generation, and so on and so forth. So yeah, just again, so we first have this more standard score distillation style approach where we first optimize a static shape as depicted here. So this again shows the different camera renderings. For that, we now use both this multi-view image diffusion model and this text-to-image diffusion model. So this multi-view image diffusion model, it simultaneously gets, gets renderings from the 3D objects that we're optimizing from certain camera angles. And yeah, it makes sure they're all properly consistent and 3D consistent directly. This helps with the 3D consistency. One issue is this multi-view image model was trained on like a lot of synthetic 3D data, and therefore has a little bit of a visual bias towards how these 3D shapes look like. While this text-to-image model that we give as additional supervision here, it has less 3D understanding, but higher individual image quality. So again, combining these different models helps. Formally, on the more mathematical side, what we are now strictly speaking, is that we now optimize this reverse Kullback-Leibler divergence from the rendering distribution over the product distribution of these two models. We can think about this as a form of compositional generation where you combine different models together so that whatever we generate has to obey both distributions, both the 3D distribution defined through the multi-view image model and the image distribution defined through the diffusion model. And then in the second stage, as I've explained already, yeah, we do this deformation field optimization with the dynamics where we feed, where we basically feed these videos and renderings both to an image model and a video model to get the temporal dimension too. Again, we can think about this as a form of compositional generation, where we optimize this distribution between the rendering distribution, the video renderings now, and the product distribution of this video and image model. So what's the type of things we can now generate with that? So this is quite different from image generation or video generation or even static 3D generation. And this, like directly generating these dynamic 4D objects had been quite underexplored when we started working on this. So here are a couple of these dynamic 3D shapes that we could like generate from scratch here. Here are a couple of more, and there are some interesting things to point out here, both in terms of possibilities, but also limitations. On the one hand, we see that even in this very challenging dynamic 4D content creation setting, the model is able to do this kind of zero-shot generalization towards prompts that are very different from what the model has seen during training. And it can learn to combine these different concepts, like of a monkey and the bass guitar, and of which there is probably very little explicit video data out there. On the other hand, in all these examples, you see clear artifacts. This is by no means perfect, right? Sometimes you even see these individual points flying around, which is literally an individual of these 3D Gaussians. So while I think this is quite cool, what you can do is here, it's also very early on and far from mature. Here a few more examples. So we played around also with not just objects, but landscape things. It's a little bit of a feel for water motion. Maybe here for this fire, you see this oscillatory motion. This also suggests that there is something wrong with the model under the hood. This is likely due to some sinusoidal encodings in the MLP that defines the deformation field leading to these artifacts. So there's lots of room for improvement. Yeah, here's a little bit more. Something we can also do that should play. Yeah, no. You can change the text prompt while you are generating these things. So now here we have these two characters, and they change from running to walking to dancing. And this gives you some additional control in terms of steering the model through text prompts. You can take all these different 4D objects, you can compose them into scenes in virtual worlds, like here, and do fun stuff. Yeah, this is just a set of all the assets we generated, I guess, for this work. You can also do funny things like that. That is a scene that we generated for the holidays in December last year. But this, per instance, 4D object optimization is actually really, really slow. So generating each individual of these instances of these dynamic assets actually takes many hours due to this iterative optimization process and the score distillation process. And so this is, while it's cool what you can do when composing all these assets, and we haven't quite seen this before like that, it's not really interactive at all and really cumbersome. So that's a bit of a problem. So, and because of this, I want to briefly talk about this work here. This is a large 4D Gaussian reconstruction model. So this is a very different type of work that is very recent. I'm not sure if that's even released or not. Anyway, so I also want to point out most credit for this work does not go to me, but for instance to GRA and intern at NVIDIA who did an outstanding job here. So what is this work about? So the name reconstruction already indicates that it is not purely generative, but has a different twist to it. So in fact, in this model, we do something slightly different. We assume we have an input video given, and then we infer the dynamic 4-dimensional, like, or the moving 3D of this underlying this video essentially. But now if you have a video given, this video can be, well, a video you took yourself, or it can also be a video generated by one of the famous video models. And these, while they are still somewhat slow, they are at least not subject to this slow score distillation-based process. So yeah, here the pipeline is more like you either generate a video or you have a given video, and then you have this feed-forward model that then generates this 4D object, this dynamic 3D object from the video. Okay, so how do we do it? So we have the video given, and this is indicated here on the left-hand side. And it's an input monocular video just from one view. And now you take a first model and you take one of the frames that will now predict multi-view images from this one frame. So this is a model called image stream. So for one frame, you now also have 3D consistent multi-view images of that. Now you copy those over to the other frames, but this is more just for convenience reasons. So overall, you then have this monocular video, like one video from one view. And for one frame, you also have multi-view inputs, 3D consistent. And now you feed all this into like a big neural network, which has this UNet type architecture. So the shape of this object is now like, it's a bit complex. So let me go over that. It has a batch dimension for different elements in a training batch, or when you generate, it has a temporal dimension, it has a view dimension, these are images, so they have a height and width dimension and a channel dimension, which initially is RGB. So this is now all processed through this big unit here, essentially. And then we have these different types of attention layers. Some attention layers that, are like attend between cross views, and some of them are like in temporal dimension. All this is very much inspired by how people did these video generative models, these initial video generative models I talked about earlier, where you take an image model and then you insert the temporal layers. You can think about this model quite literally as a 3D version of that, where you have a fixed 3D model and then you add these temporal self-attention layers. Anyway, so you predict all this feed forward, and then for the different time frames, the model will, at the end of the day, spit out a set of Gaussians for each of these frames. And yeah, this then looks essentially like that. Let me again go over the different ingredients. So the 4D representation here is not, it's just a fixed set of 3D Gaussians with a deformation field. So this model generates a separate set for the Gaussians for each time step, essentially. Moreover, the model is initialized from a model that was beforehand trained just as a 3D reconstruction model, where you're given one single input, and then it creates 3D Gaussians. So this is a large Gaussian reconstruction model. That is some previous work that takes a single view as input, then predicts multi-view images, and then the 3D Gaussians. And then we add the temporal attention layers inside the model. This is completely analogous to essentially video models. Early video models were extended based on image models. And the pipeline then overall goes for the overall model. You have this single frame. You predict these multi-view images for this one frame. And then the multi-view image plus the monocular video then leads to these 4D Gaussians. Yeah. There is also some 4D Gaussian interpolation model for smoothness. There is some autoregressive reconstruction model to run the model over and over again if you have very long videos. And very crucial to actually train this, I should emphasize it's probably much more, is we had to collect a new training data set to train such a model. So this is trained on like 100,000 animations from the observers data set that were all rendered in multi-view consistent videos for supervision purposes. So this was a large part of the project to collect and prepare this data for training. Because the training objectives, this reconstruction objective is, when you predict these Gaussians as output for your pipeline, you render them from different camera perspectives. And well, now you need some form of supervision like that can properly, fully in 4D supervise. So full multi-view videos, 3D consistent multi-view videos for supervision. So that is what we created there. And this is a pure feed-forward model, right? While this text to 4D setting I described before, we had this hours of optimization. This model, given an video, it takes 1 second to generate the 4D object. So this is way faster and way more useful potentially for that reason. So the types of results that you get are like that. So here on these little rectangles, these are the input videos. So all these videos are basically mostly taken from different video generative models out there. And then you can turn them into these little funny like 4D shapes. These are a couple of examples. This is an example of this interpolation model. I don't know if that's visible online or properly on the screen, but hopefully. Anyway, without this interpolation, it's quite jumpy, the motion, but you can make it a lot smoother. We can also have this autoregressive generation for like somewhat longer videos. So these videos here are longer and the 4D sequences. At the same time, this also shows some limitations. If you, for instance, for this dancing kangaroo, I think this was from some video taken from some video by Sauer, where we segmented out the kangaroo and reconstructed it in 4D. You do see inconsistencies here and quite a few artifacts. So when you have models that are longer, that have particularly much motion, things do start to break at some point. So again, this is just very exploratory work on like 4D content creation, unless image video. Anyway, I'm not sure how I'm in time, but probably I'm running out of time. So let me come to a conclusion. So I think in general, like these modern generative models, also some of these reconstruction models, they can certainly be a powerful tool for artists, designers, content creation broadly. But many things are missing, right? We need controllability of these models. We need faster models. And then what I talked about here, it's also like this new frontier of generating more like directly in 3D, not just images and videos, or like even dynamic 3D. Can we generate this directly and do cool things with it? I want to emphasize that I personally believe from the technical perspective, there are really exciting opportunities at the intersection between 3D and 4D and image and video models, in the sense that, you know, you can take these image and video foundation models, use it to like optimize 3D and 4D shapes based on them. But I think it can also go in the other direction that, you know, explicit 3D and 4D data models can help us to, you know, have like better controllable image video models that will lead to have a better 3D understanding of the world and maybe some camera controllability. So yes, it's quite an exciting research direction, and we're only really at the beginning here. I briefly want to acknowledge my collaborators and co-authors for all the different work on like video and 4D generation we did at NVIDIA. And yeah, thank you very much.
So we will go through this poster session. Sorry, I'm not showing it sharing on screen in Zoom. But yeah, these are the 8 posters, and the posters I think will be presented in Arch 4, if I'm not mistaken, and these are the number 41 to 48. And yeah, so Julia, now you can take over to show the spotlights.
Fine-grained fashion retrieval, FGFR, aims to retrieve fashion items from a database matching specific and detailed query image attributes. This task requires a model to discern intra-attribute, subtle, and viewpoint variations, which is more challenging than general recognition tasks. Existing methods follow a pipeline of extracting image features using the ImageNet pre-trained CNN backbone, and then pay more attention to designing complex attribute-guided embedding modules for a more powerful attributed-aware representation. They often neglect to enhance the discrimination of the CNN-extracted image features. A better image embedding leads to a better attribute-aware representation. Furthermore, while much focus has been placed on designing complex attribute-guided attention modules, other techniques that could enhance the similarity learning have not been thoroughly explored. Consequently, 2 critical questions remain unanswered. Question 1, how to extract more on designing complex attribute-guided attention modules. Other techniques that could enhance the similarity learning have not been thoroughly explored. Consequently, 2 critical questions remain unanswered. Question 1, how to extract more discriminative image representations? Question 2, how to learn similarity information more effectively in FGFR. To address the aforementioned issues, we propose an online knowledge distillation KD framework that leverages KD's advantages in feature extraction. We also introduce a novel relational knowledge distillation, RKD, strategy that outperforms conventional item-level KD by focusing on relational information. The proposed KD framework and RKD strategy can be seamlessly integrated into existing state-of-the-art SOTA FGFR models and have experimentally verified to significantly improve SOTA methods' retrieval accuracy.
Excited to present you our work. Fashion item recommendation model in hyperbolic space. Visual information is particularly valuable for recommending items, especially in the fashion field. A variety of recommending tasks based on the visual information have been developed. Hyperbolic space is a non-Euclidean geometric space with constant negative curvature. Previous work showed that the property of hyperbolic space is well suited for modeling hierarchies and has been used for representation learning of various tasks. Based on the findings of previous work, This study aims to propose a new visual recommender system with hyperbolic embedding. To the best of our knowledge, hyperbolic space has not been used on visual recommendation paths. Our proposed model first extracts the user's preference vector through a neighbor attentive aggregation layer based on the user's past item history and image data. The loss function includes a ranking loss calibrated in hyperbolic space and a loss that adjusts the positional relationship in hyperbolic space and Euclidean space to be consistent. From this page, I will introduce the evaluation experiment. The setting is as this page. This result demonstrates that our proposed model outperformed our baselines on 3 datasets. It highlights the effectiveness of using hyperbolic space for fashion item recommender systems. Additionally, we investigated the impact of hyperparameters on recommender performance and interpreted the obtained user item space. The conclusion and limitations are described on this page. Thank you for your watching our presentation.
Street try-on, learning in the wild virtual try-on from unpaired images. Here, virtual try-on is an image generation task to dress up a given person using a given garment. The prior try-on work focuses on studio images, which means the garment and the person are always from a studio source in a standard pose and with a clean background. However, the existing virtual try-on methods cannot be generalized well to solve the in-the-wild try-on problems. Here is why. Prior work often requires paired images to train. The paired images are usually studio images collected from online shopping websites. Therefore, the existing methods trained on studio images cannot work well for the in-the-wild cases because of the distribution shift. Unfortunately, we cannot train those existing methods on the in-the-wild data directly either, because there is no in-the-wild data in pairs as required.
Hey, Julia.
On the observation,
We still have some issues. Can you share again? We have issue with audio, like before. Maybe it's my computer. Yeah, can you start this again? See if it works.
Learning in the wild virtual try-on from unpaired images. Here, virtual try-on is an image generation task to dress up a given person using a given garment. The prior try-on work focuses on studio images, which means the garment and the person are always from a studio source in a standard pose and with a clean background. However, the existing virtual try-on methods cannot be generalized well to solve the in-the-wild try-on problems. Here is why. Prior work often requires paired images to train. The paired images are usually studio images collected from online shopping websites. Therefore, the existing methods trained on studio images cannot work well for the in-the-wild cases because of the distribution shift. Unfortunately, we cannot train those existing methods on the in-the-wild data directly either, because there is no in-the-wild data in pairs as required. Based on the observation, in this work, we propose a method to directly learn virtual try-on from unpaired images. First, we propose a new benchmark for in-the-wild virtual try-on called Street Try-on. Derived from Deep Fashion 2 dataset, Street Try-on has 12K training images and 2K test images. Here is the proposed method. Given the person image and the garment image, first, we use a warping module to warp the garment to fit the person. Meanwhile, we remove the person's original outfit by a diffusion scan imprinter. After that, the processed garment and the person will be composed together, and we will refine it to get the final try-on results by a diffusion refiner. There are 4 trainable components, and all can be trained without paired data. Our method achieves plausible results for in-the-wild try-on and outperforms prior work for cross-domain try-on. Thank you for watching, and more details can be found in our paper.
Hello everyone, I'm going to present our work titled Artifact Does Matter, Low Artifact High Resolution Virtual Try-on via Diffusion-Based Warp and Fuse Consistent Texture. In Bertrand technology, one of the biggest challenges is achieving realistic fitting of clothing on human while preserving all the fine details. Existing approaches, especially those using GANs as their backbone, often produce noticeable artifacts. On the other hand, diffusion-based methods struggle with maintaining consistent texture and suffer from high computational demands. To overcome these challenges, we developed a two-stage diffusion-based Bertrand method. We first designed texture warping module, which offering a novel alternative that breaks down the complex warping task into a sequence of simpler, more controlled denoising steps. This aims to enhance texture stabilization and ensuring more consistent patterns. Then we introduced the texture fusing module to fuse the human and closing textures. This module reconfigures the latent diffusion model to exclude cross-attention, enabling direct high-resolution try-on synthesis with 17 times inference-time acceleration. For the experiment results, we compare with the existing state-of-the-art high-resolution Bertrand methods. As we can see, our approach can better ensuring both closing warping stability and texture fusing consistency. Our method also shows the competitive score in qualitative results compared to existing sodas, and low computational time compared to other diffusion-based methods. This is the conclusions. Thank you for your listening.
Hello, I am Yafei Mao, an applied scientist at Amazon. Today, I am excited to share our work on a simple strategy for body estimation from partial view images. Accurate body measurements are crucial for modern online shopping experiences. Traditionally, this involves requesting full body photos along with height, weight, and garment sizes. However, it can be inconvenient for customers, especially in confined spaces, as they need to place the phone far enough to capture the whole body. One of the main challenges with partial body images is the unknown scale, whether the body is truly bigger or just closer to the camera. We propose a straightforward and modular solution to move the subjects to a fixed capture distance, which we call height normalization. Specifically, we utilize an off-the-shelf CNN model to detect body joints. Then, we derive the simple body based on height and gender, projecting the joints to 2D at the designated locations. We establish an affine mapping between the detected and the designated joints, followed by warping the image accordingly. This approach can serve as a pre-processing step for human mesh recovery networks or body estimation networks, enhancing body measurement accuracy. We curated a training dataset comprising 6,100 individuals and report the top 90 percentile error on a partial view image dataset containing 400 subjects. When training with height normalization, it can lead to up to a 2-inch reduction in TP90 error in the human mesh recovery networks or body measurement estimation networks, demonstrating the effectiveness of our proposed approach. This concludes my introduction to the paper. Thanks for listening.
Creating an immersive virtual conducting experience. Conducting a symphony orchestra is a quite mind-blowing experience. However, it is reserved for very few individuals. With this motivation, we are creating an immersive virtual conducting experience in the high-tech Dome Theater Wisdom of Tekniska Museum in Stockholm. In the installation, the user will be surrounded by the 180-degree projection of a recording of the Swedish Radio Symphony Orchestra and have control over the timing of the recording with their gestures. The user's movements are captured and fed into a gesture recognition module, producing a time signal that syncs the video and audio playback. An instructional video will offer a crash course in the conducting while visitors wait in the line. It will be premiering in 2025. For this installation, we recorded the Swedish Radio Symphony Orchestra on February 21st, 2024, conducted by Daniel Harding, performing the first 90 seconds of Beethoven's Fifth Symphony. This recording, made by Ivar Studios with a 270-degree wide-angle camera, will be edited into a DAW video that plays at variable speeds, controlled by the user. The professional sound recording will be used as a soundtrack. To train the gesture recognition module, the conductor's motions, hand gestures, and head gaze direction were captured. Besides, we will gather additional conducting motions for training. 10 to 20 conductors will be asked to pretend that they conducted specific recording and be recorded with the exact same motion capture suite as the original conductor. We will train a neural network that over time takes the new conducting motion and outputs a timestamp in the original recording's frame number or bar progression. Different models such as LSTM or transformers will be edited for this task. As an initial feasibility study, we recorded a professional conductor's motions with a metronome, synchronizing the motion with the beats and labeling each frame with the progression within the bar. We trained an LSTM model on this data to show the methods are suitable for this purpose.
Hello everyone, my name is Eugene from UNIS. Today I will present our research on human AI co-creation in fashion design ideation and sketching. Our motivation comes from recent AI advances, offering tools like ChatGPT, Midjourney, and DALL-E that enhance artistic expression. These technologies speed up the design process and reduce the need for physical materials. Our research explores generative AI in fashion design, focusing on idea generation and sketching. Our research questions are: how do designers engage with generative AI? When to stop and why to iterate? What are the values in various visual elements? We designed 3 experiments: an offline workshop with 7 participants, a hybrid sketch interview with 8 participants, an online focus group discussion with 11 participants. Our key findings are: when fashion designers input prompts for image generation, the level of prompt detail could impact the AI's ability to generate images that closely match actual garments, although this may not always reflect the designer's initial concepts. Introducing unpredictability mirrors real-life design experiences and enhances creativity by fostering unique connections between existing ideas. The process of human-AI collaboration highlights that AI generative design tools significantly expand the scope of visual exploration for designers by providing a diverse range of concepts and images. Designers prioritize visual fidelity and realism with aesthetics and composition, practicality and wearability, originality and creativity. And designers' input and customization also rated highly. In summary, AI has been shown to enhance creativity and open up new avenues of data exploration. AI can inhibit the deep reflective thinking that is critical to the traditional design process. AI cannot fully replicate the nuanced ideation process driven by human creativity. That's the end of my presentation. Thank you for listening.
Cool. Let's thank the authors, right? The spotlights. And so they are here, obviously. So the poster session, I believe it starts at 4. So go and ask questions about their paper, their post, and yeah, we'll be back at 11 here again for the second part of the workshop. But we will have other 2 invited talks. Yeah, thanks. Cool. Can you hear me from Zoom? Well,
Yes.
cool. Let's get started again for the second part of our workshop, and we will have 2 keynote speakers. First, Jason, talking about good art is of manifold. And yeah, Jason, you can take the stage.
Hi, everybody. This will be an artist talk. So I've got lots of slides. Let me share screen and get that organized. And then I can sort of introduce the talk and myself. Let's do this. I'll do the share screen now. Okay. So just want to thank the organizers, Zayed, Loris, the team for the invitation. I loved speaking to, I'm an artist, but I have worked closely with computer vision researchers on and off for, probably 20 years now. So I really enjoyed the opportunity to speak to vision audiences. And I wish I could be in, was at CVPR last year, and I'm unfortunately not able to make it this year, but so I'm missing Seattle. Okay. So as I said, this is an artist talk. So that is a sort of typical standard form for artists to present their work in public, and it tends to be a kind of overarching narrative of a practice with some thematics and focus. So I will be showing some older work, but that is sort of the natural part of the process. And I think that the things I've chosen to talk about today, I feel like are really germane to what's happening now. So I will be starting like into the 90s, but I think it's worthwhile. I'll also do some historical framing, even older work, and then for me, the most exciting part, toward the end of the talk, I want to spend some time on speculation around how we can move image systems for more deep, rich cultural uses, and move their outputs off manifold, which is something I've really become interested in and concerned with. I have a painting over here. I like to show this painting in the beginning of talks. This was a painting that was hanging above my bed when I was 5, 6, 7 years old, painted by my father. So it kind of gives you some sense of the background I came from. I come from a fine art background first, rather than a sort of math or science background, which I did get really interested in math and science sort of on my own in school, but my household was a real artistic and creative environment. Okay. So before I get into it, I do think it's worth asking a question: is what do we mean by art? What exactly are we talking about? I'm a professor and I teach art to both undergraduates and graduate students, and I teach it in a traditional art department, which doesn't intersect that much with computer vision or AI. So when we're talking about that, it's more of the things on the right side of the screen. So we're talking about historical fine art, and then I spent most of my career in contemporary art. This is a project by my recently passed colleague, William Popel. This is at the Whitney Museum, and these are 1,000 or so pieces of bologna that were left untouched during the entire run of the Whitney Biennial in, I think, 17 or 18. But I think for the purposes of this talk, I would grant opening the word art to include all sorts of visual culture, from logo design to special effects, across a spectrum, and to think of the kinds of use cases of vision and contemporary AI being across this entire gamut of visual culture. Again, most of my experience is in contemporary fine art, which is actually somewhat far away right now from activity of image generation and the technologies that are being rapidly developed. So just to say, most of my opinions about this sort of span this gamut all the way from sort of visual design, graphical, so UX, UI, architecture included, all the way through contemporary fine art. So before I get into it too much, I do want to just point out that generative systems for making artwork or making sort of image artifacts are quite old. They go much further back than this, but I do think I was born in 1970, and there are two interesting parallel, in some sense, projects that were going on at the same time. Sol LeWitt is a sort of, at this point, archetypal conceptual artist who wrote really simple algorithms for drawings to be drawn by teams. Those drawings had innate variability within a really narrow sort of bandwidth. And then on the right is John Conway's Game of Life, another rule-based system for generating black and white imagery. I'm sure most of you are probably familiar with. I just have a couple slides about these artists or mathematician. So this is a Sol LeWitt piece called Wall Drawing 51, and the titles of his works typically are also the algorithms for their creation. So the rules in this case are all architectural points connected by straight lines. These are two separate installations of these wall drawings at different locations. So based on the location, you would get natural variability of the kind of drawing possible. And of course, the definition of an architectural point is subject to some disagreement and dispute. So you'll have natural sort of human judgment that's impacting the reproducibility of these drawings. And this was avant-garde. This was the sort of most far out art one was getting in 1970, certainly in the kind of mainstream contemporary art, and really I did think has a prescience about how algorithms could be used to make imagery. Then obviously Conway's Game of Life, I won't spend much time on this, but also another rule-based system generating complexity. And I show these in classes still, and undergraduates are still astounded by the degree of complexity and richness of emergent sort of phenomena that come out of such a simple, sort of dumb in a sort of formal sense project. I'm still taken with these and both their imagery and their, for me, real philosophical heft. All right, so I had seen that. I'd seen the Game of Life. I'd seen Richard Dawkins' Blind Watchmaker software in my undergraduate days, and by the end of undergrad, I was pretty convinced I wanted to sort of design software processes and write software to make art. In this case, I was fully oriented toward gallery and museum fine art, but I was convinced that there was this possibility of making software that you collaborated with or sort of let run amok. In this case,
sorry, Jason, we had some issues before. I can't hear your audio again. Can you try to share again?
Yeah, can you hear me?
I don't know.
Can you
share
hear me?
your screen again.
Unshare and share.
Sure. Why we had that also with the previous virtual presenter.
Okay.
Oh no, yeah, can't hear
I'm
you.
sharing again. Can you hear me? Can you hear me?
Can't hear you. Nope. Can you try to unmute or?
Yep.
Yeah.
Yep.
Yeah, we can't hear you from the room. I think or maybe I can try from here, do something.
Can you unmuted? Can you hear me now? Yes, hello.
Okay, now we can hear you. I think we had some problems with the. Yeah, now it's good. We had some problem with the. Yeah, this probably the adapter here. I don't know. It happened before.
Next time I'm gonna fly there. I'll do it. I'll do it next time.
Yes.
Okay, so should I just start with where I am? Is that fine?
Yeah. That was like the last 30 seconds, even less. Sorry about that. We had it
That's
before.
okay.
I think there is some issues with the adapter or something. Sorry.
Okay, no worries. So I was just saying that I had minored in computer science and majored in art as an undergrad, and toward the end of my undergrad, I became convinced, and this is 92, 93, I both love the idea of making software objects that would then generate, right? This is sort of before the word generative was sort of used with regard to like making artwork. And so in this particular project, I used a Mac SE, a 9-inch Mac, black and white Mac, to generate sort of this, narrow but near infinite, in human terms, infinite variety of sort of these carpet-like forms, and simultaneously was making a book of word-like forms. And so even then, I'm kind of thinking both along linguistic and visual ends. So most of my work has been in the area of imagery, just for detail. the physicality of the object has always been important to me. So these were printed and bound as 350-page books. They were shown in my undergraduate thesis show. This one is, I guess you'd call it like an expert system, where I was taking what you might call tokens. I had subdivided sort of my own interpretation of natural language into sort of three parts: beginning consonants, middle vowel system, vowel sort of token, and ending. And so, and it's funny because these words like token, they weren't available. I was just thinking about how do I generate sort of goofy 1 or 2 syllable words, some of which you get real words and mostly you don't. And that sort of especially with the carpet piece, the surprise. So I'd run this Mackie connected to a dot matrix printer, wake up in the morning, and I'd have maybe 30 new prints or 40 at best. And the surprise of what was possible, what kinds of things came out of this algorithm, was really exciting. And that sort of excitement is with me to this day. It's very similar feeling to the last thing I'll show in this talk. So just sort of tells you, I've been interested in this space of a relationship between artful intention and autonomous sort of partnership with process for a very long time at this point. So I'm going to jump around quite a bit. It's not a real long talk. So, but related to that piece, maybe 9 years later, I'm represented by galleries. I have gallery representation in New York and Chicago, and this was actually shown in Seattle, where you guys are. That was gave me an opportunity to focus mainly, almost completely on making fine art and selling it, but using computational processes. So these are 3 sort of aspects of a project called Golem, where I wrote, designed a software system to generate 100,000 abstract paintings that were sort of borrowing from second generation abstract expressionists and from Richard Diebenkorn. These are some different manifestations of it. I like the printer a lot, but the thing I actually like the most is later I did an online version where I just had all 100,000 paintings. So this is the 100,000 paintings sort of from the first painting that the process generated up in the upper right, all the way over to the last. And these striations, what I would do is I felt like I was sort of a painting farmer, and I would, this was much more rapid. I'd have some hundreds of paintings, and I would change the algorithm every day. So it wasn't a fixed algorithm. I'd go in and tweak it. And so as you sort of scan this, it starts out very what I would call sort of primitive, simple. The rectangular forms are pretty simple. I do like the subdivision of the surface. That was something I was really keen to work out, like a personal algorithm for how to interestingly subdivide a surface. But as I was working on it, this was maybe 6-month process. I would explore different ways of that the algorithm can go, always rectilinear, but and toward the end of this process, I'm making sort of what I would call pretty mannered. That is, you've kind of exhausted the capabilities of a system and the system starts getting weird. We use that term around the history of painting, Renaissance painting. People think about El Greco as being sort of a prime example of a mannerist, because he began to really play with human proportion. And the speculation would be around that once a form gets so exhausted, you have to start doing weird stuff with it. So this is Golem, and it was really, and I showed this at Art Basel, and it was a really interesting intersection between a kind of subtle argument toward the algorithmic. Is it possible to algorithmically intersect with creativity? And that I got a lot of mixed feedback. There were people that were challenged or uncomfortable with the idea of making a painting generator. And I don't claim these paintings are great. There are some gems in here, but the process I'm really proud of, and I'm proud of the sort of the entity of these 100,000 paintings. Another aspect of my practice, I'm sort of poking at the generative aspects of my practice. I've been working publicly since the 90s. So I have a lot of work, and the themes tend to be around, can we sort of manipulate and organize data for meaning, or can we generate things given some pre-existing form or genre? And that those two things are really sort of interrelate. The idea of generating 100,000 paintings autonomously, or the idea of this case of taking genre photographs and averaging them. And I would say this kind of work, I did this quite a bit in the 90s and early 2000s. This kind of work, I think, is how I ended up sort of interacting with the computer vision community well before neural networks. So this is 100 photographs of a newlyweds, 100 photographs of kids with Santa, 100 photographs of the Little Leaguer, and 100 photographs of the graduate, all just mathematically averaged. In this case, I'm actually taking the median and the mean, because I was sort of getting interested in trying new things to make these photographs. So, in 2004 and even in the late 90s, I'm on sort of older computers with like directories or folders full of imagery that are of some genre. And I've thought of them as data, and I thought of myself as working with data, but now it's really clear I'm building my own data sets to make art with. Just another aspect of this project, I sort of played with experimentally sort of figuring out, when does the sort of individual disappear? When does the aggregate sort of take over? Usually around 25 images in a well sort of organized category, you kind of lose the aggregate. You're already getting really close to the final image. And it kind of doesn't matter which 25 you choose. They'll all, if they're sort of well organized, and in this, some of projects I did not align. In this project, I did a little bit of alignment manually, I had an assistant align actually with my instructions, because I kind of want to be distant from that process. In any case, it was interesting to me, and maybe still is, how few images it takes to sort of arrive at a kind of uber averaged image. Lastly, with these is just, I'd mentioned that I was playing, for the most part with these earlier projects, I was taking mean average of these sort of photographic genres. And I was really curious what the median was like. And, you'll see the newlywed median to mean, and the Kids with Santa median to mean. I always think of it as the median, has actual pixels from the images. And it sort of has a crunchier quality, whereas the mean is pixels invented via pure averaging, and it has a kind of airy quality. And I like that this sort of distinction between the mean and median of the exact same images does have a kind of visual, explanation. I'm interested that there is sort of a meaningful difference between the two that resonates with the nature of the two processes. Okay. So I do want to talk about, especially to this audience, how in the last 10 years, I found myself sort of getting closer to the computer vision community, to research, to the sort of most advanced work in generating images and analyzing images via software, which we would now call like AI. I was fortunate enough to be invited to be the artist in residence at MSR, at Microsoft Research in 2014-15. So I lived in Seattle for about maybe 9 months. I was invited by Michael Cohen, who was really generous to let me just explore computational photography group. There were a lot of great people there. Many of them are now at Meta AI. I think Michael is running the Gen AI group, Rosh Gershik and Larry Zitnik. Many people I met and had really fruitful interactions with while I was there. And I consider that a really interesting time. It's neural networks are just starting to sort of propagate through the research community as a way of doing classification, was I think the task. But when I got back to Chicago after that sabbatical at MSR, I immediately attempted to acquire a bunch of GPUs and got a grant from the Neubauer Collegium here at the University of Chicago, and built a small group, and immediately, within a year, was designing our own GANs and doing our own training, and I was really bit by the bug, and I was very excited about the possibilities, and literally just, I have just terabytes of imagery and video of experiments with GANs and autoencoders and things like that. I founded a company called Latent Culture. It still exists, and we deployed some iOS apps with onboard sort of AI, cool photo sort of tools and effects. Right before pandemic, I was in LA a lot working with the South Park team on, they were going to do a deepfake movie. It did not happen, but that was a really interesting experience. So this is all to say, like, my fine art gallery museum practice has continued throughout, but I have become really more deeply engaged with the capabilities and possibilities in neural networks, etc. And then that has led to work on papers. So a few published papers, including being the senior author on a paper at ICCV, which I'll talk about in a second. And as well as doing large scale commissions with neural networks. It's interesting right now, I perceive something of a backlash to, with the advent of diffusion models, something of a backlash to AI, especially in the contemporary art community, and even in the broader sort of art making community in general. And I have some thoughts about that and how we might navigate that as well. So I have a team in Chicago. We're making models. I've been making art for a long time, and I'm interested in how to sort of stay true to my vision, the vision I've developed over a lot of years, and what these tools can do intuitively, not sort of. I recommend artists not force it. Dance a dance that you have sort of natural capacity for, comfort with, love for. Don't chase trends. But for me, having my whole adult art making life has had me work around generativity and around big folders full of images, and so AI was very natural. Like, I took to it really quickly and naturally. So this was the first sort of really large scale thing I was able to do, and this is in 2018. But we're still talking about StyleGAN might be out. I think this is based on pre-StyleGAN architectures. So we're writing our own model we called Genmo to take patches and reconstruct them in some other trained space. And the other part of this is really important was, how do I work big? How do I work high resolution? I don't want to make 256 at that point, 256 by 256, or if we're lucky, 512 by 512 squares. That's a very limiting way of thinking about art making. So I endeavored, and still do, to use tiling systems to build much bigger images and videos composed of, at least partially composed of, model output. So this is on the first commission for the Art in the Mart program here in Chicago. I was the inaugural artist, or inaugural artist. There was a group of 4 of us, and the Merchandise Mart is a massive building. So this is a very massive opportunity to make work almost entirely sort of GAN generated, or at least GAN using our sort of in-house GAN autoencoder hybrid. That's this. So it sort of, the fun of AI, certainly then, I think still, was this, swapping parts. I called it flipping triangles. playing with encoder and decoder combinations. In this case, we're taking the bottleneck of an encoder and using that as the prior to a GAN, and there's some reconstruction losses, etc. UChicago encouraged me and applied for a patent. We were awarded. So it was a kind of interesting, weird thing to do from a fine artist perspective. This is just a little snippet of the project. So it's 5 minutes plus, maybe 5:30. So a long time in a lot of rendering. And it's a 6,000 wide 6K video. So sort of thinking through, how do I use tiling and reconstruction from some sort of input patch? How do I, given these tools that I've generated, how do I make something? The theme of this project is exploring design and art history in Chicago, along with some pop culture elements and a kind of painterly psychedelic, maybe. So you know, this was sort of the largest fine art project I was able to do during the pandemic. And it was really wonderful, actually. It's quite sustaining to have a museum sort of follow through with a commission right in the heart of the pandemic, produce this completely remotely. I never was on site until after it was installed. Lots of interesting video calls when we're trying to figure out lots of details, but it's a 72-foot long photographic mural that adorns the photo galleries of the Museum of Fine Arts in Houston. They had a new building, the Kinder Building, which is their sort of modern and contemporary expansion wing that was under construction pre-pandemic and finished during the pandemic. And I was invited to produce an artwork to adorn the exterior of the photo gallery. And so I was thinking about photo history and things like that, and ended up using ImageNet. So I sampled the entirety of the full ImageNet library with the full category list, which I think is like over 20,000 categories. There's the reduced size and the full size. And sampled every category to get about 300,000 individual images that are then sorted to make this pattern, this sort of, I don't know, I call it like a waterfall sort of pattern. It's still up to this day. So if you're in Houston, you can see this. This is a sort of an interactive version of the wallpaper. And so my goal was to be sort of clinically truthful about the content of the data, while also making something, to my mind, like a beautiful aesthetic experience. And so each category is a little run of luminosity, dark to bright. And so that gives it this shape. The dimensionality you see is just a particular category sampled. I think it was sampled between, say, 9 to 12 images or something like around that. And so there's no sort of design for this pattern, except for a kind of fairly simple algorithmic design applied to a data set. And the data set has, based on its numbering, has some natural order that comes out in the visualization of it. So, you can tell this is organic material versus, there's like a household goods area. And so there's no manipulation, it's just the reorganization. And like I said, this was I felt sort of satisfied and lucky to be invited to make this piece and to think about a kind of absurdity of like all of image space. Obviously ImageNet's this incredible moment in vision where a model, while low resolution and incomplete, does sample a big amount of say, the internet's image space. But there is something, especially to the people outside of the community, there's something kind of absurd about a kind of claim around capturing sort of the totality of image space. I think we see this now with other models and their claims to capture the totality of text space. when it's really text-based on the internet, which is not the same thing. So the title of the project is, the title of this talk is Good Art is Off Manifold. And all I really mean by that is that I'm really interested in diffusion models, and but they are, people have gotten, my perception is that the world has gotten quickly bored with the sort of native outputs of diffusion models. And I think when the video models come online, Sora, et cetera, people will be super excited and then will quickly get bored of them. And so I think we have to really be thoughtful about what do we do with these amazing things, not with this sort of the fun of what happens out of the black box, you know, a file, and you post on the internet and people, and you get some likes and some laughs, and then it's completely forgotten about. And so my impression is that we quickly understand the model's internal capacity, the space of imagery, and we become quickly adapted to what's possible, and the model basically does not ever go outside of those expectations. So when diffusion models first, sort of prompt-driven sort of models first came online publicly, people were amazed and were having such a good time, you know, making sort of surreal combinations of, you know, a dolphin on a unicycle out in space. And those were fun for a second. But it seems clear to me that they're not fun anymore. And that happened really fast. And I think it has to do with a kind of ease of consumption, a kind of uniformity within the image. So images collage, but not really easily, and a kind of arbitrariness of control. Now, obviously, there's a lot of work going on this. This is, I think, you know, what people are really concerned about. How do we control these things? So I'm not the first person to make these observations. But I do think exploring what it would be like, what does it even mean to try to get outside of the manifold of a trained model, or the manifold of the potential of a model with trained weights? That's something I'm really interested in, and to what degree it's possible is an open question, but I think artistically it's super interesting. And, you know, what I would say, these sort of like good art is off manifold, you know, we get really excited when people surprise us artistically, discoveries in science, etc. One definition of genius in my mind is the degree to which someone is able to sort of step off a kind of manifold of expectations in discovery. And can we get trained models to do these things, right? They ingest and interpolate with their hyperdimensional interpolation, but they're still interpolation within a set. So these are kind of open questions that excite me. And I would say this sort of, you know, black-white dichotomy I've set up here is a little extreme, but I do want to point out, like, the idiosyncrasies that humans apply to art making are lacking in what models can do, whether we're talking about really practical use cases or whether we're talking about sort of fine art or really exploratory use cases. I think in all cases, whether it's a website design, we want some discovery, we want a little idiosyncrasy. Maybe we don't want it in our banking website. So maybe models will be really good for helping make banking websites. But I'm talking more about sort of deep, what I would consider like deep experimental culture. So I'm gonna move to wrap up, but I did want to sort of point to some. I've been on. So as an artist, I did not expect I would be working on computer vision papers. And the other big project I did during the pandemic, we had been working on a model that can kind of combine ideas in the work of Spade, using segmentation, et cetera, to help control outputs, and style gain injection. We sort of hybridized that and made a model for in-house use, just for artistic use, called Sensorium. That was fairly open-ended in the kinds of conditioning modalities it would support. So you could use pose, you could use segmentation, you could use depth, you could use kind of any of the standard off-the-shelf models that generated conditioning information about imagery. And we thought of that as the content.
Sorry, we
and
lost
it
you
kinda-
again. Oh,
Ah.
okay. No, now it worked. It
Okay.
works.
Okay. How much? I know we started a little bit late. How much time do you think I have?
Yeah, it's fine. Then, yeah, go ahead.
Okay. All right. Yeah, we ended up with the encouragement, I think, of Nick Culkin, who I've worked with quite a bit, who's now at Adobe Research. We thought, this model is interesting enough. Maybe we should make a paper out of it. It's pandemic. We're all remote anyway, and so we endeavored to make a real paper, and it's presented at ICCV 21. It's the first and maybe last time I'll be the senior author on a paper. I don't know if this is my bag or not, but I definitely enjoyed it. I enjoyed learning about the sort of nitty gritty. There's a dance in fine art, there's certainly a dance to how one's work enters the world, how one's work enters galleries and museums. There are different kinds of conventions and strategies that are mostly intuitive, but they do exist. And I learned about the sort of, at least a little bit about the computer vision version and appreciated that. So this model, what I'm most proud of is the model does a lot of the things that ControlNet does for diffusion models. And while we didn't, I don't think people recognized it at the time. We didn't open source it, so there's lots of things we didn't do. I had this intuition that from an artistic perspective, at least can I do pose? Can I do, and can I do it nicely? And can I do it across different kinds of training data and have it work? This is just a pose sample output, and it looks GAN-ish. It has some GAN problems, but it's a kind of morphing of GAN and style transfer that was exciting to work on. Okay, so we're getting to like my most recent work. This is a project just from last year. It's an online project. It'll probably have physical manifestation, but it's called Totem. It's essentially a 10-second GIF that's 100,000 pixels by 58,000 pixels. That's why it's sort of online as its primary. And if you can notice, like the projection on the merchandise mart, the wallpaper, I'm really interested in how to use these, how to collaborate with these processes to make things that are quite big. And this is basically 5,226 10-second stable diffusion animations that use all kinds of priors to sort of coordinate large-scale imagery, etc. And they're based on, the prompts are driven by the most popular, most visited pages on the Wikipedia. So it's kind of a, tile, from the largest tiles being the most popular Wikipedia page to on this one, the smallest being the least. I'm going to just jump to the site just to show you a little bit live. And this won't take too long. I've done three versions, so I really am interested in sort of how to automate large-scale production. This was a real early version, as I'm sort of figuring out how to do things. These tiles all have an interface. There's sort of like, they're all sort of independently acquirable objects. And this is all just running live from a server. There's lots of adventures in React web design and how do you make a huge animation. It's just essentially using sort of a map-based backend, but all of the sorts of things that I had to learn to make. There wasn't like a rule book on how to make a super large but short animation, and so these kinds of things are still really exciting to me. This is using kind of diffusion models a little bit out of the box. I mean, we're or off the shelf, I should say. they are, in inheriting a kind of pre-made sort of under, think of it as like an architecture of video underneath that's sort of focusing on the tile or focusing on the big aggregate. So the piece moves through these different spaces. But it's new. It's about a year old at this point. That's still new to me, and has had some public participate with it in interesting ways. And so this feels like a first version of something. I mean, it itself has 3 versions, but I feel like the kinds of, so like, the fact that it's all gridded, we definitely have ways of doing kind of blending so that we might make a more seamless kind of world. So the possibilities of making really large scale things are present and interesting and continue to be interesting. Yes.
We have one minute left.
Yep. Let me get to the thing I want to talk about the most then. Okay. So this is work in progress, and I just started doing it in April, so it's really new. And Nick is Culkin at Adobe is advising and helping, and I have a student here who's doing a lot of engineering, Hyder. This complaint I have about the that even the weirdest outputs from a prompt kind of meet expectations at this point to some extent. That complaint is something I've decided to address directly. So we are building systems to modify pre-trained models at the layer level and in combinations of levels with all kinds of essentially randomly generated but meaningful functions. And so this system will ultimately be deployed as a true synthesizer outward facing. So you'll be able to come to a synthesizer and make things, and just a few outputs. And I've only been working with this synthesizer myself for like 4 weeks. So I'm just learning what it can do. And these are transformations applied to, say, this set of layers that match this string primitive. When particular discontinuous functions are applied to this layer, you might get outputs like this, depending on the prompt. Really abstract things, and then more of the kind of oddities that you might expect, but would be hard to imagine how to make a prompt to do this. So we are currently building this thing, and then this might intersect with the larger scale things. That's what I'm working on right now. I'm having a blast with it. It's some of the most fun I've had. I do have a level in this particular case. We'll run an experiment and have 2,000 outputs, and I'll look at them in the morning and basically kind of select ones I like to further refine in the secondary interface. And so that has been it's been real fun work, and it reminds me of the carpet maker thing I showed at the very first. This idea of waking up in the morning, looking at a bunch of outputs, selecting ones you like, and then maybe refining them. That's been a real joy. So I'll leave it there. I am totally open to conversations with like-minded collaborators. I would love to collaborate with vision people who have an interest in these sorts of things. You can get either my Instagram, my Twitter, Jason Sullivan Studio, or at Sullivan. Happy to answer some questions. Thank you.
Thanks, Jason. Thanks, Jason. Any questions from the audience here in Seattle? Can you come here? Yeah, we have one.
I'm doing like generative R right now, and currently also like at the Blackberry stuff on the generative AI and also stable difficulties kind of stuff. So I wonder, so I just made some work myself, and do you have any suggestions for people just at the very early stage for how to prepare artwork or how to draw the community?
Did you hear or?
I did not hear.
Yeah, maybe you can come here to the podium. Sorry. Yeah,
Okay,
just speak. Yeah.
Hi.
Hi, Johnson. Thank you for a really amazing presentation. And let me introduce myself briefly. So my name is Aria, and I've just started to do some like generative art with stable diffusion, etc. And currently, I'm also work at the Meta Research for the generative AI research. So I want to promote my artwork and trying to join the community. So do you have any advice for people like me, just at a very, very early stage, how to do this kind of work? Thank you so much.
Yeah, of course. That's a great question. There is a kind of bifurcation, balkanization happening in the art world. So there's a fine art community, galleries, museums that have been interested in sort of digitally made artwork for quite a while. And you'd be showing at a gallery that maybe show paintings and sculpture and show, your installations or your prints that sort of had a lot of the digital in their DNA. There is more recently, it seems like people who are doing sort of real AI-driven work or really working in pure file form, like the final output is a file. Twitter seems to be the place that people are finding audiences. I would recommend exploring, is there an object form that these things might take? I want to sort of, we're getting pretty comfortable with looking at things on our phones and thinking we're seeing greatness. And I'm not sure we are. And I would just make an argument for objecthood, and even just making a thing as a print and putting it in a frame and lighting it is like an interesting and maybe non-trivial thing to explore. So, of course, I think it's awesome that you're working in these ways, and Twitter does seem to be the place where people are finding audiences, but I wouldn't eschew physical objects as well.
Yeah, thank you for the good thank you for the good advice. And do you
course.
think are there any ways for me to try to find some like collaborators, or is there possible to, for example, collaborate with you? Because I really like the your artwork, like the pixel
Sorry,
like
we need to get that.
oh yeah, sure.
Maybe you can reach out.
Please reach out to me. I'm happy to.
We are a little bit
continue,
late with the program.
Happy to continue the conversation.
If the next speaker is already here, can you start it up? Jump in. Sorry about that. Thanks, Jason, again. Let's thanks the speaker. It was a pleasure to have you here.
Thank you. Thank you for having me. Appreciate it.
Okay. Hi.
Bye-bye.
Yeah, I need to set up here. Let me mute myself. So yeah. So yeah, he's gonna present exploring new perspective with computer vision. Please go ahead.
All right.
Thanks.
Awesome. Thanks. First of all, thank you very much for inviting me. So this workshop is about fashion, art, and design. So it took a long time for me to kind of accept this invitation, because I don't really kind of consider myself associated with these words. So kind of I'm usually a little sloppy, and then I don't really have a lot of artistic skills. So here are some examples. So last week we brought my kids to have a ice cream for celebrate his birthday. And after that, my kids draw a picture, and then my wife said that he's drawing better than me. So this is one example that I'm really kind of bad at artistic skill. All right, but because I know a little bit about computer vision, so I figured that I will share a little bit of my work on computer vision. Like how do you kind of, because you are equipped with this computational power, how you can create new perspectives for visual arts. Okay, all right. So, as like 40,000 years ago, like human already start making pictures, either through the drawing on the cave, or with better tool, you can draw better pictures. And now with the invention of the camera, you now can capture the reality with just a snapshot. And with now everyone has digital photography, and you can actually capture memorable moments of your life to create kind of this like a visual snapshot of your life. So this is all pretty amazing. And this happens kind of, as you can see that all this kind of technology advances change how people create visual arts. And then that changed. And then in 2022, if you are not living under the rock, you'll see the, okay, sorry. You see all the kind of amazing breakthrough in generative AIs. Right? So it's all kind of, all these are, you can just type into what you want to create, and they will just generate it for you, right? And in 2024, right now, we have seen like a tremendous progress in all this field, and we see, sorry. Right. And we see all this kind of amazing technology. For example, all these big players release their own text-to-image model that all generated like beautiful results. But does that mean that we kind of the art is done, like artists just die or something like that? So I really like the quote of one of the American painters. That is like art is really an experience, not an object, not a particular object that you created. It's the experience that you crafted so that your audience, your reader, will be able to experience that what you want to convey. And so with that idea, I was thinking about how we can use computer vision to kind of enable you to create visual art. And one way to do this is that those kind of experience, traditionally, those experiences are usually 2D, right? So if you have a painting, you have photograph, it's always 2D. Or you have sculpture, you can look around. So all these are kind of static experience. So I was thinking about how we can create new experience with computer visions. So in this talk, I'm going to talk about how we can explore new perspectives. So specifically, I'll talk about two main aspects. The first one is that how we create like a view consistency, starting from something that's static to create something that you can explore, kind of immerse yourself in. So that give the user, to give the people their own perspectives, to explore new perspectives. So this is about consistency. Another perspective is that, okay, maybe we don't really need a consistency. Maybe it's more interesting to create inconsistent results. And so this is something that I'll talk about in the second half of the talk. Okay. All right, so let's first dive in on the view consistency, right? And specifically, I'm interested in kind of two main modality. One is photographs and videos, things I couldn't draw very well. So for photography, this has been kind of probably one of the most important invention of human history, is that you can kind of capture capture and share, communicate visually by just simply pressing the button. And so these are the kind of important photographs, and either it's for beauty or for capturing that historical moments of human history. Without this, we couldn't really convey or kind of educate or share kind of these common human emotions. Right. So so when I look at all these photographs, how can we make them interactive? How can we make them bring new perspective into this, kind of bring all these photographs to life? So a couple of years ago, I I have a work that look at how we can turn this photograph into 3D. So I'm just showing some of the results. Oh, it also has sound. That's good. So basically, what we do is that you take the picture that you have, and then you kind of lift it up into 3D so that you can actually really experience that photograph at that moment, but from a new perspective. All right, so I feel that this is a lot more immersive in compared to standardized like conventional photographs. And of course, you don't need to restrict yourself to be at like in the past, right? So for example, you could create a new experience of your own photograph. So I try that, and this is our like my kids, and you can recreate this kind of experience very in a fun way. So it feels like it added another dimension into the visual experience that you created. All right. So how does it work? So here I just give you a high-level sketch of how the major kind of method. So you start with let's say you take a picture of this boy and in the snow. So you have the snow, and what's the physical model behind these photographs? So you have a boy here, you have some tree in the background, and then you have some light that reflect that emit light source, and then you have you capture photographs that from this light in first surface, and you capture this photograph. And the photograph captures is only the visible surface, like it's only the first intersection of the scene. But what you didn't know is that the obstacle here is that you don't know what's the invisible part of the scene. Like, so this is something that a challenge we need to resolve. So we start with estimating the depths using molecular depth estimator at that time, so that you can parameterize the scene with the depth map. So you can lift this thing to 3D. But when you try to create a new perspective, you'll see holes, right? You see missing pixels. So how do we kind of impend this? Like, so basically we need to hallucinate new content so that you can visualize the whole thing from a new perspective. So the idea is that very simple. You want to hallucinate in the back, but you cannot really impend every view independently, because that way you won't achieve view consistency. So the idea is very simple. You start with you have a local edge, depth edge here, and you know that this some region is closer, some region is further away. So what you do know is that you know you can cut this edge off, and you want to impend the content. The trick here is that the foreground regions and the background region, they are not relevant. So you really need to define where the context you can use, what the content that you need to use to synthesize this picture, right? And that way you can impend the back of the face, then so that you get a really nice layered depth image representation. That allows you to kind of view this from different viewpoints. All right, so this is a kind of probably 3-4 years ago. So since then, you probably can see a lot of like Facebook has 3D photos, and Google also have this kind of dynamic photos that are all based on similar methods like I described here. All right, so now we can deal with photography. So what is the next step, right? So next step is obviously videograph. So we run from a long way from having the first video captured in 1878 with this horse example, where they try to kind of capture how really the horse moves over time. And this is not really easy because they move very fast. So if you don't really capture it, you couldn't really analyze them. And if you fast forward to today, now we have like a tremendous, like an incredible text to video generation system that just stream up pixels from text prompt, like and then all these are pretty temporal consistent, and they all capture this. So it's allowed, like I think that the technology here is that it can democratize all this kind of high level videography and like planning and all these skills. You no longer need those skills. You just need to kind of dream out the content you want. So that freed up a lot of like a technical burden from everyone. So what we can do here from here is that, again, these are just videos, right? It's just the 2D plan and all these things. No matter how the camera moves, you just fixate on that specific viewpoint. So what we can do here is that we can create a new perspective, like create a new 3D video. So here is some example that you can do. For example, if you create from a video, you create a 3D video. Now you can render the stereo video and consistently, so that you can actually have a depth perceptions, just like any movie. So this is one way you can think about. But also you can do something even more. For example, you can create a space-time view synthesis video. So you can pause at any time. You can look around the visual things you just created, and then you can explore the scene. Basically, you can immerse yourself in the scene, and because this is can run in real time, so you can actually kind of experience the visual thing you created, but from a new perspective. Okay. And of course, this also kind of works for synthetic data, like generated data, but also work for real data. So you can actually kind of recreate a memorable moment of your life, and then kind of have enable people to have the new perspective on the data. So yeah, so this runs on real time, so you can actually kind of it runs on real time, but with a GPU, so you can actually kind of play around, and then so here is a demo where you can actually move around and then can synthesize new view while you are playing the video. All right, so how does it work? It's actually very, very simple. So you're given a video, you need to kind of extract basically the kind of primitive of the videos. So basically you need to know what the video depth is. Oh, sorry. You need to know the video depth. You need to know where the camera is, and you need to know what are dynamic, what are static. And this will be handy later on. So once you have these things, you can use this kind of components. What we did is that you can feed a representation, 3D consistent representation for the background. So in this case, we use a mixture of planes. So basically, you can think about it's a 3D Gaussian splatting, but in 2D. Okay. So the reason why we want to choose this kind of representation is that, like for 2D Gaussian splatting type of method, they really work well when you have a very large viewpoint variation. But most of these like casual videos, you don't really have that kind of parallax that would allow you to train this model. So you really need to, and planar structure is very easy to handle. So once you have this, you are able to kind of fit this model, and then you can allows you to render this dynamic video, the static part of the dynamic video from any different views, right? So, and this is the kind of the results, and like you compare to kind of 3D Gaussian splatting or other representation, it won't be able to kind of capture this this kind of more weak parallax cases. Right. For foreground object, it's very easy. Once you have all this video depth representation, you just fuse them in the world coordinate, and that allows you to kind of recreate a foreground, what a foreground dynamics will look like. Okay. Then once you have this foreground dynamic and static components, you can fuse them easily with like depth order composition. So you can create something like this. So if you look at this video, you can actually see that the camera is actually freely moving after the fact. Okay. All right. So this is about like creating a new experience from the existing photograph and videograph. Okay. So, and then the goal here is really about like how can we deal with view consistency? Like the challenge is that how can we create something that's view consistent so that you, when you view from different viewpoints, you still the same. You still get the same experience. But if you look at this, I think a lot of time in order to create something unexpected, something that's interesting, something that's novel, you sometimes need to be inconsistent, right? So let me talk about some two examples that how you deal with that. And I'm very much inspired by this the artwork gallery from Michael. So what they did is that they create this kind of, you have, when you, from this viewpoint, you have all this gun, and they come up with they form a picture of America. So it's kind of highlight the gun violence problems in USA. And then when you the audience or reader, when you move across, you have to experience yourself, right? You have to change your perspective, and you will see a different interpretation of the scene. I think that's super cool, right? So you can have kind of convey what the experience, connect the with the people in a new way. So this is very cool. And I also find that the other type is that instead of these objects, you can use wire. Like wire art is very simple, but you can see that you can create a 3-dimensional wire art. By the way, this is not my work. So this is the artist I'm inspired from. So you can create a new perspective. And let me just play that again. So you start from giraffe, and then when you move your position, you'll see a different image, like it become morph into an elephant. And all these 3D structures are connected so that they can you can be physical. They won't float in the air, so they can be physically stable. So that's very super cool. So I think I want to make something like this. But of course, I am not, as I said, like I'm really not that artistic though. So, and also it takes probably 3 to 4 months to create each one of this. So I still need to earn my paycheck. So it's really hard for me to do this. So, but what can we do? So what we can do is that, okay, so instead of having this kind of create this art from scratch, maybe I can create, I can find the drawing, 2D drawings very easily, right? So you can have the 2D drawings, and then from the 2D drawings, you can see, we can define a 3D representation of the line structures so that you can design the line structure so that it fits your 2D images, okay? So that's very, very simple concept. And this is the example. So you can see that this looks like a 2D drawing. It's a car, but you can, this is actually a wire structure. If you move around the wire structure, you can create, and it actually convey the energy like you don't drink and drive. And so here, what you're seeing here is that you see from this viewpoint, and we shine a light from another viewpoint, so you see a shadow from that. So you can see dual representation at the same time. But this was meant for kind of artistic rendering of what will be physically there. Okay, and of course this is like a graphics object, but it's kind of just a bunch of lines. But we can do more. We can, for example, because we say that we need to be all this information need to be connected. All these wires need to be connected so that you can physically produce them. So we try that. So all this kind of, once you create this wire art, then you can, so this is the installation of our artwork in a campus cafeteria. So you can actually create this kind of 3-dimensional artwork from a bunch of nerds. Like we couldn't do this on our own, but we use a computation with computer vision technology. We can now create interesting art like this. Okay. So all these are 3D printed and then put in together. All right. So what's more interesting, I think, is that computer vision and those techniques not only can kind of help assist enhance the art, it can also go beyond what artists cannot do. Like give you, just like at the beginning of the talk, I show you like different tools you can create different new experience. And what we go beyond is that the artist does never show a 3-view multi-view wire art. Then but it's very easy for us to using computer vision and computer graphics techniques. So here you show that actually the same 3-dimensional object, but you can actually shine light, and you can see the projection there. You can see 3 different interpretations of the same artwork. Okay, and we try different variations. For example, here is angels. So you can see that all this kind of visual concept. As long as you get a sketch and you can recreate this kind of 3D wire art. So the artist, the French artists that make this wire art, they make this elephant and a giraffe. We can recreate it like his work, and we do even further. We add another view that I'm not sure whether he can do it or not. Maybe he can. But this is for us. It's actually very easy for us to do this. To create like multiple different interpretation of the same wire art. All right, so and these some more examples where you kind of create patterns, create different different animals and so on. Right, and you can also do something like interesting, like you can like just grab your presidential candidates and create this kind of more things. So I was imagining that this could be used for example, for kind of outdoor instrumentals, displays. So you can actually visualize this. You can actually have people to walk around and see different interpretation. So some other kind of configuration that we try, like you can have this kind of wire art, different things, and you can create different walking patterns and so on. And something like about art is about this. A lot of times it's about it's personal experience. So I create this my two kids the portrait, and I could create this kind of wire art so that I can actually 3D print it in my home, that I can create this this new experience. Okay, so this is great. Of course, this is all. This is like a couple of years ago, and recently, I think this CVPR also has some work that kind of extend this to using generative AI. So instead of having a actual sketch that you draw, you can use something like using just text, and you can optimize these lines so that you match. You can create different sketches from different views. All right, so this is cool. But if you look at all these kind of examples, like when you have created the wire art using the either it's kind of line drawings, or in this case, it's a kind of shadow drawing. This is another artist rendering of all this exposition of all this kind of trash. But if you shine light from one particular viewpoint, you see like very interesting patterns in the back. So I think this is very interesting. But if you look at all this visual information, you'll find that this is not really, they're just simple images, right? How can we create more, like not just for single images, but also appearance, okay? So here's some recent work that we've been doing. So you can actually create, like I said, you have a 3D object of a box. You can create a new experience. For example, this is a bird, looks like a bird. And if you rotate this 3D box, you can create different images like this and become a waterfall, become a garden. Okay, and another example where you can create so this is a soldier, but the soldier's part becomes the campfire scene, becomes the background. The campfire scene, part of the campfire scene becomes a garden again. So you can actually kind of share all this information, create a visual experience. Of course, you don't need to be just a box. You can create different visual representations, such as like you have a ball here, and you can, when you rotate these different viewpoints, you get new visual effects. You have different visual interpretation, not just that go beyond just a wire or shadow. Okay, some more examples. Get a Bruce Lee here. If you look around, you get a landscape thing, right? All right, so we can go beyond just a single object, single 3D object, but go beyond to something reflected objects. So this is the artwork. I think this be our inspiration. So what you see here is a 2D paper on the ground, and then if you put some cylinder that's refractive, you'll form interesting images up here. So what we tried is that we tried to do the same thing, but now let's say this is the actual feature is the iPad, then you display the image. We can create this. This is and you can recreate this. And once you zoom in, and if you there's some images hidden in these things, and you have to find for it, right? So you have to put this like cylinder refractions, and you have to search for it, and at the right location, you'll find Nemo in these things. Okay. Right. So it becomes a new way of creating art. Like, so I'm not that artistic. I don't have the artistic skill to really create this, but you can use computational approach to create this. So here's another example where like this heaven, and you can create an image of your dog. If you like pass away, you can create this kind of artwork. And this also works in real physical world as well. So you can have a canvas, you can actually create this kind of visual explorations. So since we are about like a search, so I figured out. So you can see you need to search for it. Like, yeah, so you can see the dog face. Right. Since about search, so as a dad of kids, so I usually want to like demonstrate that I can find the waddle. So so we thought like maybe we can create a 3D version of this, right? So this is a like random beach scenes, but if you look closely, you'll be able to find a waddle, and in 3D, right? So you can find a waddle in 3D. That's I think is super cool. So you can create a new form of new media of people engage with visual information instead of go beyond the 2D world, right? And I think you just sent me this. Like she can also do the physical world explorations. So you can find where that waddle is, and you can find by placing the things. Look around, you'll be able to find waddle. Okay, this is here. Right. So and all this information are hidden in the top-down view. So, right. So I think this is kind of fun way. All right. So I talk about like how we can do the inconsistency in terms of wire art or anamorphic art, and we also talk about like how we can create view consistent result from existing photographs and videographs. I want to take a moment to kind of highlight the students. This is basically the students who drive these projects that make this wonderful work. And I want to thank you for your attention, and I'll be happy to take any questions. Any question? Yes.
Very nice talk. I like it very much because I'm also working on computer vision, but like thinking something about like creating art using the computer vision technologies. But I have a question. So recently, like we have like this visual model, a lot of like content generating models, but like the data is always the problem. And like in particular for creating the arts, actually like you need to feed the model with the data, right? Then how do you collect data, and then all this data actually are from the artists, and they have copyrights actually.
Right. Yeah. Yeah.
So you cost a lot to collect the data. Then like yeah. So I'm very curious like how do you address this?
So that is a very complicated problem. I don't think anyone has an answer for that. So basically, this will come down to attributions, like how your model kind of get this particular styles, and that's coming from a particular artist. And this and people need to do the content moderation, like how can I use this data? And there are like a whole legal team usually on working on these type of problems on whether you can actually use this information. So and So I think there's some way to address this. For example, you could potentially provide incentive, because right now the main difficulty is that all these artists, the work getting reproduced, but without getting compensated. Like their work is not paid. So there's several different work where you can incentivize people to contribute to this model, and kind of how to so that you will have a more powerful you can think about all these diffusion models are kind of like a very large prior, right? So it can allow you to create different expressions. Yes. Yep.
So do you mean that like from the technology perspective, actually we need to figure out how to use this kind of data efficiently? I mean, like before that,
yep.
Any class we do feature learning, we just use few examples to let the model know what we want to do. But right now, like we're doing content creation, so actually
yep.
we're modeling the style or like the pattern of the artist, and then we also want to make model generalize to like a new like context of the artist. So
right.
That's like kind of like.
So there are multiple aspects. I think one aspect is about like how the artist relationship between these kind of models and the artists. Another one is, of course, like what you said, like how can you learn this efficiently? Like if you don't have like Van Gogh doesn't have like a gazillions of visual data, but this current model seems to be able to do a pretty good job in terms of like generalizing this kind of visual representation from a very limited examples. And that's kind of what we see so far, that you never see an astronaut like riding horse, like you never see these kind of images, but you can compositionally, these models are able to kind of dream up these kind of configurations that never seen before. But of course, there's a lot more work to be done in terms of in this space.
Thanks. Any more questions? No more questions? Okay, cool. Thanks.
Yeah, thank you. Thank you.
Now it's time for closing remarks. Well, we're taking over. Hello, can you hear me from Zoom?
Yes, we hear.
Okay, cool. Yes.
Can you share the screen on Zoom?
Yes. Thanks for a reminder. Yeah, I'm gonna be doing the closing remarks. Can everybody see it from Zoom? Everybody?
Yes.
Do you see the?
We see the slides, yeah.
Okay. I think you see the, sorry, you saw the other view. Let's just do normal view. You see the viewers view, right?
It looks good.
Okay. Cool. So thanks everybody for attending the workshop. Pretty excited about all the speakers and posters and papers that we have seen today. Yeah, so I want to thank everybody, right? And also the authors of the papers that were accepted and presented. Yeah, so we want to actually, we have 2 awards that were sponsored by ZozoNext. So thanks to the sponsors again. And we decided to give away some GPUs, some, cool things that you can use in your daily work, hopefully. So we have 2 paper awards. One is the runner-up and one is the winner. And so I wish that the authors are here. Let's see, they are. So I want to, so first we'll give away the best paper or runner-up. And this is gonna be a GeForce RTX 4080. And so the best paper award runner-up goes to Artifact Does Matter, low artifact high resolution virtual try-on via diffusion-based warp and fuse consistent texture. And yeah, thanks. Is there any author here from this paper? Chan Chen, Che-Hyun Chen, and Hon Han Shuai? If you are here in the room, come by to receive the award. Guess not. Not here. Well, we will send out an email to the authors, I guess, to hopefully they are at CVPR at the conference, and so we can give the award. Do you want to say anything, Ziad, or anyone from the other organizer here?
Congratulations to the authors.
Yeah, congratulations. Then they will receive the GPU. We have it here somewhere. Cool. And yeah, the actual winner of Best Paper Award will get GeForce RTX 4090, so a little bit more RAM, GPU RAM. So, and this goes to Straight Try-On, Learning in the Wild, Virtual Try-On from Ampere Person Images. So let's give a round of applause. Is the author here? Not. Is one of the authors here? Maybe, maybe not. Well, no. Well, anyway, we will try to reach out to them, and see if I can collect their award. But yeah, anyway, congrats. These were nice papers. So we basically gave award based on the quality of a paper. So yeah, that concludes our workshop, and I want to thank everybody, right, that attended, our amazing keynote speakers, the authors of the papers, and thanks for the support. And I also want again to thank the other organizers that were not able to be here. I don't know if Dia, Julia, Maria, you want to say some words? You can speak now. Otherwise, yeah.
Yeah, thank you everyone for attending the workshop and making a very successful workshop.
Wait, I have some problems again with the audio.
Can you hear us, Loris?
I think it's. Can you speak?
Hello? Yeah.
Yes, we just want to thank everyone for attending the workshop, and we hope to see you again in the next round of the workshop. Thank you very much.
Thank you.
Yeah, thanks. And yeah, again, thanks to the sponsors, Zozonex and Zalando, and thanks to everybody. Thank you. Thanks. Lunchtime.